Good afternoon, everyone. We are just waiting for more participants to join. We may start in another 10 minutes, so please bear with us. We'll be starting in another 10 minutes. We are just waiting for more participants to join. So please bear with us.
Mm, mm, mm. Shailesh sir, good afternoon. We can start.
Okay. So shall we start now? Okay, dear one. Okay. Uh, Namaskar to everyone and my warm greetings to all who are participating. Am I audible, Manish ji? Manish? Am I audible, Vikas?
Sir, you are audible.
Okay. So, Namaskar and my warm greetings to all who are participating in this webinar, which is the part of webinar series being held at Lighthouse Project sites. I also welcome you all on behalf of Ministry of Housing and Urban Affairs, Government of India, Building Materials and Technology Promotion Council, GIZ, and also on my personal behalf. This is the sixth webinar, and it is being held today at Agartala site. I extend, our Joint Secretary is not here. He has to go on an official tour, but I take this opportunity to thank him for his constant motivation for conduction of these webinars across the country. I also greet and welcome Shri R.K. Gautam, who is Director Housing for All 5, Shri Manish Kumar, Lead PMU of PMAY, and Shri Vikas Ranjan, Director Climate Smart Buildings, GIZ. These three are also the co-hosts of this webinar along with me. We also welcome other officials from Ministry, PMU team, GIZ team stationed at various LHP sites. The dignitaries, engineers, and officers from the State Government of Tripura, SLNA, that is the State Level Nodal Agency, TUDA, are also welcome, including SLTC, CLTC team, engineers, and architects of other state level agencies. I also welcome representatives of Messrs. Mitsushimi Housing Private Limited, Ahmedabad, and their entire technical team who are executing the project and also the technology provider for this project at Agartala. At last but not the least, I also welcome all the TECHNOGRAHIS who registered through online enrollment drive initiated by HFA Directorate and participating in this webinar in such a large number. We have now more than 33,000 TECHNOGRAHIS registered, and they are the ones who will act as catalysts to bring technology transition in the construction sector. In addition, we also have engineers, architects, planners, professionals, faculty members, developers, other technology providers, and students from engineering and architectural colleges of not only northeastern states, but also from other parts of the country. They all are welcome here. Today's webinar, as I told you, is being held at Agartala, Tripura, which is one of the LHP or Lighthouse Project site under Global Housing Technology Challenge. And first, we will give you a brief exposure to the latest innovative construction systems shortlisted through GSTC India and being promoted within the country, followed by a technical presentation of the specific technologies being used in this project. Just to give you an idea, we are, right now doing 6 lighthouse projects which are being implemented in 6 places, namely Rajkot, Chennai, Indore, Lucknow, Ranchi, and Agartala. At all these 6 lighthouse projects, 6 distinct innovative technologies are being used, and we are holding these webinars at all these 6 places for participants to understand these systems. These lighthouse projects are also being projected as live laboratories, which means learning by doing. Okay, learning by doing the different aspects of transfer of innovative technologies to the field, which includes planning, design, production, assembly, erection, construction practices, and quality control and quality assurance. Through these lighthouse projects, our objective is to encourage large-scale citizen participation, and that is why we are doing it as a continuous activity and create technical awareness for on-site learning. And encouraging innovation, thereby mainstreaming these proven innovative technologies in Indian context. And there are a whole set of activities being planned at LHP sites, which includes not only these webinars, but webcasting, physical training, site visits, and interaction. It offers all of us a unique opportunity to learn the field level application of innovative construction systems in real time and build capacities so that these systems can be further adapted, suiting to our requirements and geoclimatic profile and replicated in our future construction activities. The use of these innovative construction systems is relevant in today's context and quite pertinent as globally we are committed to bring sustainable development, which includes resource efficiency, energy efficiency, eco-friendliness, disaster resilience, and lead our country towards sustainable and inclusive development. Also, to take our country to $5 trillion economy, construction sector is going to play the most important role, and so therefore we need to fast track construction of buildings and infrastructures. And these technologies which we are going to deliberate which we are going to share with you in these webinars, impart not only speed to the construction activity, but also deliver superior affordable housing and infrastructure, which is better in terms of structural and functional performance, quality and durability than the conventional cast in situ RCC framed and brick construction. So far, 5 webinars have been organized at one each at Rajkot, Indore, Lucknow, Ranchi and Chennai. This is the 6th one. We would be holding 40 webinars, so you can join us in all these webinars as per your availability. During this webinar, we will also be taking you to a virtual tour of LHP site to take stock of the present construction activities and give you hands-on experience on the construction technologies and processes being used in this project. It's friends, it's a unique opportunity where theory is being blended with the field exposure. I sincerely hope you all will be benefited by this webinar and learn new methods of construction, which will help you in your future endeavors and in your projects. So with this, I once again welcome you all. And before we get into the technicality of these technologies and the specific technologies being used in this project, I would request Manish to run a short film, which is of 5 minutes, specific to this lighthouse project at Agartala. So Manish, if you could play that film.
Sir, we are connecting the video. Can I request everyone to please switch off their mic?
Please, Bindu, I think your mic is on.
Is it visible to all?
Housing
Yes, go ahead. Very good.
has initiated Global Housing Technology Challenge India to identify and mainstream best available global technologies so as to bring paradigm shift in the construction sector. 54 innovative technologies put in 6 broad categories were shortlisted during the challenge process. 6 lighthouse projects at 6 locations with 6 distinct technologies are being constructed. Lighthouse Project, using light gauge steel structural system and pre-engineered steel structural system with 1000 dwelling units in G+6 configuration, along with all basic and social infrastructure facilities, is being constructed at Agartala in partnership with State Government of Tripura. Honorable Prime Minister laid the foundation stone of 6 lighthouse projects, including at Agartala on 1st January 2021.
आज गरीबों के लिए, मध्यम वर्ग के लिए, घर बनाने के लिए नई टेक्नोलॉजी देश को मिल रही है। ये 6 लाइट हाउस प्रोजेक्ट देश में हाउसिंग कंस्ट्रक्शन को नई दिशा दिखाएंगे। अगरतला में न्यूजीलैंड की स्टील फ्रेम से जुड़ी टेक्नोलॉजी से घर बनाए जा रहे हैं। जहां भूकंप का खतरा ज्यादा होता है, वहां ऐसे घर बेहतर होते हैं।
After obtaining all statutory approvals, the construction of LHP Agartala started from June 2021. Due to the poor soil conditions of the site, piling work up to 30-meter depths was planned. Piling work involved boring, placement of cage and bores, assembly of reinforcement cage, casting of piles with concrete, excavation, breaking of pile heads and testing of piles. Massive work of about 1700 piles was started in a phased manner, out of which about 1500 piles have been completed, which includes all the required piles of 4 towers, and remaining are in advanced stages. Laying of plain cement concrete, footing work, shear wall, casting of plinth beam and backfilling to complete the substructure is in progress in 4 towers. After completion of foundation work,
मनीष रुक गई बीच में, फिल्म बीच में रुक गई मनीष आपकी।
being manufactured.
Manish, it is not moving, it's not coming.
At site.
Manish, you have to play it again because
Should we play it again, sir?
yes, because it got stopped in between and after that there was nothing.
All right. So we'll start again, sir.
Okay.
Ministry of Housing and Urban Affairs, Government of India, has initiated Global Housing Technology Challenge India to identify and mainstream best available global technologies so as to bring paradigm shift in the construction sector. 54 innovative technologies put in 6 broad categories were shortlisted during the challenge process. 6 lighthouse projects at 6 locations with 6 distinct technologies are being constructed. Lighthouse Project, using light gauge steel structural system and pre-engineered steel structural system with 1000 dwelling units in G+6 configuration, along with all basic and social infrastructure facilities, is being constructed at Agartala in partnership with State Government of Tripura. Honorable Prime Minister laid the foundation stone of 6 lighthouse projects, including at Agartala on 1st January 2021.
आज गरीबों के लिए, मध्यम वर्ग के लिए, घर बनाने के लिए नई टेक्नोलॉजी देश को मिल रही है। ये 6 लाइट हाउस प्रोजेक्ट देश में हाउसिंग कंस्ट्रक्शन को नई दिशा दिखाएंगे। अगरतला में न्यूजीलैंड की स्टील फ्रेम से जुड़ी टेक्नोलॉजी से घर बनाए जा रहे हैं। जहां भूकंप का खतरा ज्यादा होता है, वहां ऐसे घर बेहतर होते हैं।
After obtaining all statutory approvals, the construction of LHP Agartala started from June 2021. Due to the poor soil conditions of the site, piling work up to 30-meter depths was planned. Piling work involved boring, placement of cage and bores, assembly of reinforcement cage, casting of piles with concrete, excavation, breaking of pile heads and testing of piles. Massive work of about 1700 piles was started in a phased manner, out of which about 1500 piles have been completed, which includes all the required piles of 4 towers, and remaining are in advanced stages. Laying of plain cement concrete, footing work, shear wall, casting of plinth beam and backfilling to complete the substructure is in progress in 4 towers. After completion of foundation work, superstructure work of erection of steel column, beam, placement of deck sheet with reinforcement, fixing of light gauge steel frame, LGSF panel and cladding with foam concreting. Fixing of services and finishing will be done to complete the towers. As the piling work is in progress, fabrication of steel components and light gauge steel components are getting ready at site. LGSF components are being manufactured at the manufacturing yard set up at the site itself. The pace of construction has geared up and the project is expected to be completed well on time. More than 700 beneficiaries have also been identified for the project. The LHP Agartala is serving as live laboratory for learning. About 150 TECHNOGRAHIS and other stakeholders have visited the site to learn the use of innovative technology in real project at site.
Thank you, Manish. Okay. So now, now I'll make a the first presentation where I will be showing you these 6 broad categories which were shown to you in this short film, and after that we will get into the details of this lighthouse project at Agartala, the technology being used, and the stages of construction. And I will try to take you through that project through the presentation. So let me just share my screen first, and to tell you about all the technologies being used, being promoted by Government of India. I hope it is visible to all of you.
Yes, sir. Yes, sir.
Okay, thank you, Manish. Okay, so welcome once again to this sixth webinar at Lighthouse Project Agartala. And before I get into this emerging construction systems for mass housing, let me just tell you that the entire activities, this Lighthouse Projects, Global Housing Technology Challenge, Technology Submission, all these things are being done under the ambit of Pradhan Mantri Awas Yojana, and we are very, we take a lot of pride and happiness in sharing with you that we have sanctioned more, around 1.22 crore houses so far, out of which more than 95 lakh houses have already been grounded, and 57 lakh houses have already been completed and delivered to beneficiaries. And this, believe me, this figure is constantly changing day by day. And there are 4 verticals, all of you know about it. So let me not get into these details. But let me also tell you that out of these 1.22 crore houses, 16 lakh houses or 1.6 million houses are being constructed with these new technologies, which we are going to share with you in this lecture. Also, through Pradhan Mantri Awas Yojana, we are able to generate direct and indirect employment to the tune of, the 650, you can see here, generation of employment 652 and 233 lakh jobs, which is equivalent to 2.33 crore jobs have been generated. Also, cement and steel consumption, if you can see, 731 million, lakh, which means 73 million ton cement is being consumed for the construction of these houses and related infrastructure, as well as 166 lakh, which means 16.6 million ton metric ton steel is being used in these projects. So let me tell you that we organized Global Housing Technology Challenge, and this entire Lighthouse projects are the offshoot of this Global Housing Technology Challenge, which was organized on 2nd and 3rd March 2019. And during this Global Housing Technology Challenge, Construction Expo was also organized, which was inaugurated by Honorable Prime Minister on the 2nd of March. And through this challenge, we wanted to understand and learn the construction systems available being practiced world over, which can help deliver maximum number of houses in minimum time and minimum cost. And this is the sentence which you must keep in your mind, that we are trying to bring in construction systems which can help deliver maximum number of houses in minimum time and minimum cost. So when that challenge was thrown to the global players, the response was tremendous. And through that exposition in Vigyan Bhavan, we could, evaluate, shortlist, screen 54 new construction systems, which are being projected as future technologies for construction of buildings and infrastructure in our country. And what we have done through Technical Evaluation Committee, which was headed by DG CPWD, along with participations from academic institutions and research institutions, including PSUs. For the sake of clarity, we categorize the entire 54 technologies into 6 broad categories. And that is why we are talking about these 6 lighthouse projects, and each project, one category is being showcased with one distinct technology. Okay, so these categories I will be explaining you through pictures, and I will try to make my lecture as simple as I can. Otherwise, it's a very technical lecture. So through pictures, I will try to show you these categories and what we are trying to bring in the construction sector. I'll try to explain you. So as you can see, these categories are precast concrete construction, pre-engineered buildings, which is steel structural system, drywall construction, then aluminum formwork system, and stain place formwork systems. And so we have created a basket of 54 technologies, and as per your requirement, suiting to your climate and hazard profile, you can choose, you can pick one of the technology and make use of that for your future endeavors. As I told you, after creating this basket, we wanted to showcase, we wanted to spread technical awareness. We want to learn also, so that these technologies are transferred for field level application smoothly. So these lighthouse projects were initiated, and the launch of these lighthouse projects through groundbreaking ceremony was done again by Honorable Prime Minister on 1st January 2021. And while inaugurating these projects, Honorable Prime Minister desired that we should treat these projects as live laboratories. We should, spread the awareness, regarding these projects. Also, try to build capacities of professionals, engineers, planners, students, so that they learn these technologies, adapt these technologies for their future construction, and make these technologies as the future technologies for our country. Before I get into, I've been talking about emerging construction systems. It might be coming to your mind. What does it mean? So let me just first tell you what we have. All over the world, the most prevalent construction systems are these two, which are shown in this picture. On the right hand side, on the upper right hand side, what you see is a load bearing construction. And when I say load bearing construction, means you create the walls, which are essentially of brick, or it can be of a stone, and then you have a slab, which is reinforced cement concrete, or if you are in a village, then you can have a wooden truss or a steel truss, and with a roof covering of caparel or mangrove tiles and those kind of things. So that is primarily a kind of house. Isolated houses are being constructed brick by brick with this kind of slab. And now over the years, this kind of system is being replaced by this building construction system, which is shown in the right hand side bottom, in the bottom. This is typically RCC frame construction. And RCC frame construction, if I need to explain you what you see here, the vertical and horizontal members, these are the beam and columns. So the entire building is constructed with RCC beam and column. And this is called a structural system, and the structural system is nothing but the skeleton of your building. Like for a body, we have skeleton, and then we have flesh and all. Similarly, for a building, we have a skeleton, and that skeleton is called a structural system. So here, structural system comprises of RCC beam and column, and all of you know that these RCC beam and column are cast at the site. You put a formwork, then put the reinforcement, pour the concrete, remove the formwork, then do the curing, then cast the slab, and then you fill the walls with the bricks or any other suitable material. So this is what we have, and their disadvantage, their merits, demerits, all of you might be knowing, but let me just explain you through this slide. If we continue to use these are called conventional construction systems, and we are also calling them business as usual approach, because this is what we have been doing for ages together. So if we continue to use this system, what will happen is written on the left hand side. And if we replace these systems by emerging construction systems, which I will explain you in a short while from now, what advantages we have is explained in this slide. First of all, essentially, all of you will agree with me that it is a slow track construction. And that is why in most of the projects, we have time overrun. Time overrun means that if a project was to be completed in, say, X number of years, or 2 years or 3 years, normally time exceeds 2 times, 3 times. So that is called time overrun. So most of the projects are caught in time overrun. Whereas when you employ, or when you put to use these emerging construction systems or new technologies, you can fast track the construction. In fact, I will today show you a video where in 45 days, 7-story building was constructed by L&T and DRDO very recently. Then we have a resource crunch. All of you know our basic building materials, whether we talk about cement, steel, or sand, or aggregates, or for that matter, even water. All of you know potable water is being used abundantly in the construction, particularly in RCC construction. So we are using natural resources, and a lot of them is getting wasted during construction in terms of construction waste. Whereas when you have these emerging construction systems, you can optimally utilize the resources. You can optimally use these materials, because everything, all the components are being manufactured or constructed in the controlled condition. And when you do something in controlled condition or factory-like condition, you optimize the resources, not only in terms of material, but also in terms of human resources. Also, there is no wastage there. Then pollution, every now and then we are talking about pollution, and you might have seen, if you go to any project site, you will find that there is demolition waste, there is water being polluted, and all of you know that when air quality index reaches to a threshold, construction activities are put to halt. And why it happened? Because a lot of dust is being created during construction, and all these things can be avoided if we use emerging construction system, or take the construction to off-site, or take it to the factory. All of you know, labor intensive, you are dependent on labor, weather, and so many things, and that was seen during COVID time. There was some most prestigious projects came to standstill because there was migration of labor, and we were dependent on that labor. Whereas in alternate construction systems, we have industrialized system. So concurrently, construction at site as well as in the factory, you can go concurrently. So once you don't have labor at the site, you can do the work in the factory. And so that way, these industrialized systems give you a lot of flexibility. Prescriptive design and cost-effective design. All of you, if I have to explain you, all of you have grown up with 9-inch wall, okay, and without knowing whether we require that 9-inch wall or not. Okay, so that is called prescriptive design. Prescriptive means like you go to a doctor and he writes a prescription, and without asking you start taking that medicine. So most of these conventional construction systems are based on prescriptive design or thumb rules, whereas in alternate construction system, they are customized. And customized means based on exactly as per your requirement, as per your climate, geoprofile, soil conditions, everything is designed in that way, thereby giving economical and cost-effective design. Construction systems, you may not be knowing, because we are taking for granted that cement is good, plaster is good, the kind of paints and varnishes we are using, they are good. But let me share with you that all these paints, varnishes which we use, they create an unhealthy environment inside, and thereby vitiating the inside air quality. Whereas alternate construction systems, help in providing better health conditions. And once you have better health conditions, the productivity increases. Conventional construction system, if quality is not quality control and quality assurance measures are not put into practice, you might have seen that sometimes very new buildings start having signs of distress in terms of leakages and other kinds of regular maintenance is required. Whereas alternate construction system, because everything is done under control condition and it is decided beforehand, you don't have that the cost incurred for maintenance is low, and that is why we call it low life cycle cost. Okay, let me also tell you that whenever we talk about this emerging construction system, a question crops in about the cost. So the cost of a building comprises of 3 components. Okay, these 3 components are initial cost of construction, then the running or operation cost of a building, and a disposal cost. Have you ever thought, once the service life of building is over, how that building is going to be disposed? Will it be detrimental to the environment once the service life? We never think of it, because once we do the project, we go away and we think that it will take its own course. But now time has come that we have to think whatever we are creating, how it is going to be disposed, what should be the operation cost of this. And that is why life cycle cost estimations are being recommended, being stressed nowadays. And in times to come, even for smaller projects, you will have to estimate life cycle cost. And before deciding materials, technologies, and processes, you have to ascertain this life cycle cost instead of initial cost of construction. Energy intensive, energy efficient processes are being employed when you use this alternate construction systems. In fact, by having a casting yard just near to the site and just bringing those components at the site, assembling them, you can save a lot of energy. This already I covered that cast in situ, there is no control on quality. If you don't supervise it well, if you don't pay the visits to the sites, normally the conventional or business as usual approach yield poor quality structures. Whereas here you are doing everything under control condition, because if you take construction as industry, that way you are doing everything under control condition, and you're providing a quality product. That means a quality building or infrastructure. Greenhouse gas emission is low when we talk about emerging construction system, and all all these points, if you add, that amounts to unsustainable development. Whereas here the development is sustainable. So if somebody asks you what is sustainability, so sustainability can be measured in all these terms. So through these emerging construction systems, we are heading towards sustainable development, which comprises of all these things. I have also written an acronym for you. Emerging construction systems help us to build safer structures. And safer means S stands for sustainability, which I just explained to you, resource efficiency, climate resilience, environmentally responsible, affordability, in terms of cost, and also, speed, functionality. Every now and then when we talk about these systems, because we have here thinner. Instead of 9-inch wall, we can have the 4-inch, 5-inch, 6-inch wall. So a lot of questions are being raised about fire resistance, water tightness, thermal comfort, sound acoustics. So let me tell you, most of these emerging construction systems help us build buildings and infrastructure which have much improved functional performance than your conventional construction. Economical, because life cycle cost is low, and you have a better quality, so maintenance cost is less. And resilience. Resilience also, dear friends, is very important in Indian context. And India is a country. Sir, please, आप अपना mic बंद करेंगे क्या? So resilience also, I just want to tell all of you, whatever structures, whatever buildings you build, it has to be disaster resilient. Why? Because you all know that we are having recurrent earthquake. Earthquake keep coming in our country, and the places which are supposed to be safe from earthquake point of view, there also we have earthquake. And there is a history of earthquake in our country. And in addition to earthquake, we have, multiple types of hazards like cyclones every year, heavy winds, cyclones, landslides, the fire, then floods and all these things. So these emerging construction systems, help you build resilient structure, and structurally they are much superior than your conventional construction. Some of you might be, who are architects here or who are working in the area, people from, GIZ and all, who are working in the area of thermal comfort and, energy efficiency and all. Let me put this slide for you that there was a study by the Energy Research Institute, which says that, by optimizing your resources, by employing this industry or offsite construction, you can save 30 to 50% energy, precious energy. 40%, we are using potable water. Repeatedly, I'm telling you that 40% reduction in water use, 35% reduction in greenhouse gas emission, and up to 75% reduction in waste. Okay, so with this background now, I think it is clear to all of you that why we require these emerging construction systems. Okay, this is need of the hour, call of the day. And we are talking about climate change, every now and then. Today also there was a news item in newspaper that globally March was the hottest March in decades. Okay, and why it is happening? Because temperatures are rising, surface temperature is rising, and it is happening because of irrational use of building material. And construction sector is the major contributor to this, greenhouse gas emissions, using this energy and water and all those kind of things. So if we can do something with construction sectors, we can help at least going towards sustainable development, reducing greenhouse gas emission and other things. And that is why we all need to bring this change in the construction sector by using these technologies which we are talking to you today. Okay, so with this, let me just again revisit this slide that what I showed you, that through Global Housing Technology Challenge, Ministry of Housing and Urban Affairs shortlisted or created a basket of 54 new technologies. And these technologies, for the sake of clarity, we have divided into 6 categories. Okay, and these 6 categories are not sacrosanct. We have, just for the sake of clarity, we have categorized them into these 6 categories. Okay, so I will just try to explain you these 6 categories one by one. And for all these, categories, technologies, we have also created audio-visual capsules. So you can visit GHTC -india.gov.in website and download or go to my YouTube channel, BMTPC's YouTube channel, and get a whole lot of information about these technologies, their video films, audio-video capsules, lectures and all. So first is 3D precast volumetric construction, and if you are able to comprehend what is shown on the right hand side, you will understand what I'm trying to say. So this is what you see in the upper right corner is what we have. So this is the business as usual approach. What we have, skeleton of RCC beam column and then brick wall. Instead of this, what about replacing this kind of system by this kind of system, which is shown in the bottom portion in the right hand side. Okay, bottommost right hand side. So what we are doing here, we are putting one block over the other, and creating the entire building. So instead of having beam columns, these modules are constructed or manufactured in the factory or offsite, and then put one over the other to create the multi-story building. In fact, Honorable Prime Minister, while inaugurating our Lighthouse projects, said that this is kind of Lego blocks. As a kid, kid plays with building blocks and create a building using those blocks. So it is the similar technology where you use a module as a building block and then put one module over the other to create the entire building. And that is what is written here. So these are customized, factory-made, volumetric construction. Let me also tell you customized. Customized means tailor-made. Tailor-made means like going to a tailor. Okay, so as per our size, we go with the material to the tailor and give the tailor our requirement, and then he perfectly fitting to our size and shape. He or she stitches that jacket for us. So same thing is being done in the construction as per our requirement. These buildings are customized. These modules are being customized, cast, and then brought to the site and put one over the other. And another thing you might be thinking that what am I talking? This right now we are executing a project using this technology in Ranchi. So Lighthouse project in Ranchi is being done with this technology, but exactly they are putting one module over the other to create our G+8 structure. These are various stages, and again, this picture is from one of the project in Indian site. You can see this is a reinforcement cage, and then you do the molding and all. This is a mold, and where you create this module, then this module is being transported through trailers to the site, and then they are being put one over the other like this, over the already laid formation. So I hope you understood the concept. Through Global Housing Technology Challenge, we could shortlist 4 agencies who are in India presently working very actively into this 3D volumetric construction. So basically, if you are engineers and architects here, you understand I am talking about precast concrete construction. The moment I say precast means instead of casting your beam, column, structural elements at the site, we are casting them at the factory or at offsite. And what does that 3D volumetric mean? That means instead of making planar elements, that is beam, your walls and other things, planar elements, we are making the entire structure comprising of 4 walls or 6 walls or 3 walls. So that is called volumetric construction. Okay, so there are 4 agencies at present, and you can see them categorized. One of the largest company in the world working in the area of precast concrete construction. Okay, then Magic Creek is the agency who is doing our project, Lighthouse project in Ranchi, using this 3D volumetric construction, and these are other 2 agencies. Okay, and if you want to get the details of these technology providers, their phone numbers, contact addresses, and also we have published a compendium on these technologies, so you can download that from Ministry's website or from BMTPC website, or go to this Global Housing Technology website and download it. This is that project I was talking about, and this picture is old. And as I've been telling you, these projects are currently going on. So last time when I presented, it was at the foundation stage. Now already they have put those quad elements. Okay, their 3D elements have already been put, and 1-story work is already over. So this is that project in Ranchi, which is doing with this technology. Now let's move to the second. Second is again precast concrete construction, which is now instead of 3D, we are having 2D. So 2D means planar elements. Planar elements means what is shown here in this picture in the right hand side bottommost. So this is a typical wall element. So just think, instead of making walls brick by brick, you are making the entire wall. So the entire elevation is being done in the factory, and then you just transport it to the site and put it over the slab to create the entire building. So beam, columns, wall panels, slab, floors, staircases, sunshades, name the structural element or a component of a building. Kitchen platforms, almiras, everything is done in the factory. All you have to do is transport them to the site and put them erect them properly, and create your building structure. Okay, and this technology is being used in Chennai. And you can see these are different elements. There is another, this slab is also very popular. This is called hollow core pre-stressed slab. So just to reduce the weight, we create a hollow core in between, in the center, to reduce the load. So you can see these wall panels, this is a staircase. Then you can have slab, you can have slab panel solid, you can have spandrel beams. So with parapet, you can create a concrete panel. So any structural element can be created in the field or off-site, and then later erected. So through Global Housing Technology Challenge, we could shortlist 8 technology providers who are listed here. You can see some of the finest companies of the world and of our country, like L&T, Shirke. They are here, and they participated, and they are promoting this precast concrete construction. And L&T, Shirke, Volumetric, and TeamH. TeamH is the one company. They have just constructed a hospital during COVID time in 45 days, 3-story hospital in 45 days using this precast concrete construction. So I think you understood what does this precast concrete construction means. Let me also tell you, all of you might have seen how metro is being constructed. So same thing, in metro, those girders, what you see over which the metro runs, those girders are being constructed in the casting yard. So, like in Delhi or any city, they have a casting yard at few places where they, cast those girders, and one fine day, those girders are brought to the site and assembled at site, and then, metro rail, the track is prepared. So can't we do same thing in building construction? Yes, the answer is yes, and already it is being done in our country. So this is that project, Lighthouse Project at Chennai, where we are using this precast concrete construction, using these precast components. This is a G+5 structure, and already the building is already over, and very soon we will be, inaugurating this building and giving it to the beneficiaries. So that is the strength, in a time of 1 year, this project is over with this precast concrete construction. Let's get into the next technology, which is steel structural system. Again, I have divided into 2 categories here. There are 2 things, one is hot rolled steel and one is cold formed steel. Okay, I will give you details in the next lecture, because this is the technology which is being used in Agartala, where we are using this pre-engineered steel structural system with light gauge steel structure as wall panel. So what you see here, instead of having cast in situ RCC frame, we are having this kind of factory-made hot rolled steel structural system. And remember, I told you what is a structural system. A structural system means the skeleton of your building. Okay, so what you see in this slide in the bottom right portion, this is that skeleton, and this skeleton comprises of beam and column. So just imagine, instead of casting these beams and columns at the site, you are giving the order to a factory, and they prepare these built-up sections, beam column sections for you, and provide them these sections at the site, and all you have to do is you have to erect them to create this kind of skeleton. Okay, so you can see then these walls can be filled with any kind of material. It can be of brick, it can be of sandwich panel, which I will be showing you, drywall, or this is what is being shown here. This is a AAC panel in which this wall is being built. Then there is another category in this, is the cold form. So steel, can be manufactured in two ways. One is hot rolled steel, where in the furnace you roll the steel hot, and here that hot rolled steel in form of sheets is put in roller forming machines, and through that, and it is galvanized. Through that we have very light sections, C sections, jet sections, and other sections, and these sections are then converted into wall panels. Okay, so this is that kind of wall panel. Being light in weight, it can be easily lifted by 1 or 2 persons, and these panels are made in the factory and then put here as wall panels. So the entire building can be made with this. So in Agartala project, what we are doing is we are having this kind of skeleton, and then wall panels are of this light gauge panels. Okay, so again, the basic premise you might have understood now, that this RCC frame is being replaced by this light gauge steel panels. Okay, and let me tell you that 16 companies were shortlisted during Global Housing Technology Challenge who are into this light gauge and steel structural system. Let me also tell you that this technology is suitable only for low-rise structures. we have recommended this technology suitable up to G+3, means 4 story structure. Although abroad it is being used up to 7-8 structures, but looking at the geoclimatic profile of our country, we have recommended only to G+3. So if you want to go high rise, you can have a combination of light gauge with steel, hot rolled steel structural system. So it's called hybrid system, and that is what is being used in Agartala. So this is the technology, and once you have light gauge, then what you do is the outer side of this light gauge and inner side of the light gauge is filled with the fiber cement board, or you can have a concrete panel. So calcium silicate board. So what you have both sides boards, and the hollow space in between can be filled with rock wool, mineral wool, or lightweight concrete, or a proper concrete as per your application. Okay, so this is that light gauge I'm talking about, and there are 16 companies. The Agarthala project is being done by Mitsushimi, which I will be showing you in the later half of this. Now, this is that project, and Agarthala project, and will be taking you to the virtual tour of this project site as well. So there we will explain you this project. Let's move to the next category. So next category is sandwich panel system. Okay, so this is also known as drywall construction. All of you know how walls are being constructed. So you put brick over brick, then you do the plaster, do the watering and all, and then create a then do the plaster, and then you put the paints and all and create a wall. How about instead of making that wall with labor, with bricks, with mortar, how about buying a wall from the factory? It's like buying a tile. You go to a shop and buy a tile. In a similar fashion, you can buy a wall from the factory, and there are umpteen number of companies, more than 50 companies, who are into drywall construction, and that is why it is called drywall construction. Okay, and another word I wanted to explain you is sandwich panel. They are also known as sandwich panel system. Sandwich panel system means, so you have a core. This is a core which is called lighter core, and this lighter core is sandwiched between two skins. Those are called widths or outer skins. So that outer skin can be fiber cement board, it can be calcium silicate board, it can be AAC panel, it can be precast concrete panel. So you have two thin panels, 5 mm, 10 mm, 20 mm, depending upon your application, and the space between two outer skin is filled with a lighter core. So that lighter core is sandwiched between two outer skins, and that is why it is called sandwich panel system. And depending upon the outer skin and depending upon the core material, they are being named. So like EPS core panel system means we have a core of EPS. So this is also sandwich panel system. You have a EPS core. This is expanded polystyrene. It's a thermocol. If I have to tell you in loose parlance, it is a thermocol of higher density. Thermocol density is around 1 to 5 kg per meter cube, whereas the density of this material, expanded polystyrene, is 15 kg per meter cube when it is chemically treated. And then you have a galvanized welded wire mesh, and then you do the plaster, or you can do the coniding. So this is how it can be done. And this panel, because it is using EPS, that is why it is called EPS core panel system. And it can be used in variety of ways. It can be used as a floor panel. It can be used as a roof panel. It can be used as a staircase panel. It can be used as a parapet wall or a sunshade. And you can have a plaster. You can have a ganiting. You can put a fiber cement board as per your requirement. Okay, so this is that system. Now you think instead of making walls like this, get a wall, the entire wall customized, made in the factory with openings, without openings, and all you have to do is you have to just install or erect that wall on the already Okay. So there are a whole lot of companies who are into prefabricated sandwich panel systems. You can see here different kinds. So you have a fiber cement board, then you have a puff, you can have the lightweight concrete or any other thing in between. So, through Global Housing Technology Challenge, we could shortlist 9 companies who are into this drywall construction or sandwich panel system. The project in Indore is being done with this prefabricated sandwich panel system of Rising Japan. It's a EPS cement panel system. So remember, I told you, so the core is of EPS. The core is of EPS cement, and it is sandwiched between two outer layers, and those outer layers are calcium silicate or fiber cement board. So that is why it is called EPS cement board. So this technology is being used in Indore, and you can see, if you are able to see the picture here. So this is the picture from Indore. We recently did a webinar there, and we virtually we showed the participants the actual installation of these, pre-fabricated sandwich panel system over this structure. And here, let me also tell you one thing for the interest of engineers and architects who are present here, that at present these panels are being used as non-load bearing panel. The company claims that these panels can be used up to 1 story as load bearing panels. So it is recommended only up to 1 story for load bearing. Otherwise, you have to have a a separate structural system. So here the building is S+8, so we have a structural system of steel. Remember, I explained you RCC's, steel structural system. These are built up steel beam and columns, and then you are using this rising Japan or EPS cement panel as the infill walls. Okay, so this is again a dry wall, no water, nothing is required, and you can very fast erect these walls. This is what that panel which is being used in Indore. So as I told you, Rising is the name of the company, and all these panels have their brand name. Okay, so it's in building construction also you have brands, like you have in tiles brand. Similarly, for these wall panels, the companies who are manufacturing it, they have their own brand. So because since this panel is being manufactured by a company called Rising Japan, so therefore this panel is called Rising EPS cement panel. I'm not going into the detail of how this panel is being made, but the idea is it is a sandwich panel where the core is of special concrete, which is a lightweight, elevated concrete, and that concrete is sandwiched between two layers of calcium silicate board or fiber cement board. Okay. Now let's move to the next category. The next category is you might be knowing this technology because this is very popular and most widely used in our country. Earlier, people or professionals knew this technology by the name Maivan, or people used to call it aluminum formwork. Most of us know it with Maivan. Maivan was a Malaysian company who was supplying this kind of aluminum formwork, but this is basically an aluminum formwork system. Okay, and now that Maivan company is no longer there in Malaysia, they have shifted their operations in our country. Around 10 years back, we used to get this material from Malaysia, but now there are more than 50 companies.
Скимзиний богозе мама. Кона натаям корона лас перексон. Киен скимзи туру там богозе. Сама 영어자리 나타났어. 나만 말리게. 내가 영 봤어. 손도 에리지널 알스티네 양잡네.
Can you please mute your mic? Somebody is speaking in what language? I don't understand. Okay, so this is that aluminum formwork. So here, this is a customized formwork. I think all of you know about this. So, what you see in the uppermost corner is a beam column. So for beam column, you first put a formwork. Okay, formwork is a kind of shuttering. For slab, you put a shuttering. So shuttering is a steel plate, and over that you put the reinforcement. Then you cast the concrete, and then you remove that shuttering. So similarly, for beam and columns, you have a steel shuttering or plywood shuttering. Then put a reinforcement cage, put the concrete, and then remove the formwork. Okay. So instead of that, making beam column separately, what about making the entire module in one go, in one single pour? So this is customized aluminum formwork, which is made in the factory, comprising of formwork for all your walls and slab, and you just over the already laid reinforcement on a foundation, you put this formwork and do the pouring in a single pour, then remove the formwork and take it to next floor. So in fact, there is a 3-day cycle in which you can construct the entire floor, and this is very popular in our country. We could shortlist 9 technology providers who got shortlisted, but there are more than 50 companies who are into manufacturing of this. And we are doing a project in Rajkot where this technology, another variant of this technology is tunnel formwork, which is being used. This is which appears at number 8, which is a technology from France. It is Autinord formwork system. So it is called tunnel formwork. So what we are doing here, instead of making these all the 4 walls and slab, we are making 2 wall and slab. So if I have a picture, I will show you. This is the formwork system which is being used in Rajkot. So it is an inverted L. So what you have 2 long walls along with a slab being cast together. And then, so you create a tunnel kind of thing, and the outer walls are later filled with infill walls, AC block. And we are using this technology in Rajkot. And let me share with all of you that in Rajkot, what you see, this is one floor. The entire one floor comprises of 8 dwelling units. And these 8 dwelling units are being cast in 3 days in Rajkot. It's on record. External using this, may I request all of you to please mute your mic. If you're using your mobile phone, please take care of this, that you are being heard. Okay. So what I'm trying to say here, that the tunnel form right now, this eight dwelling units, each dwelling unit has a carpet area of 30 square meter. So 8 dwelling units are being cast in in 3 days, and in 8 days, and with next 8 days you go to the next floor. So it is pretty fast, and being tunnel form, being monolithic construction, there are very less joints, so maintenance requirement is less. It's being monolithic. That is why it is called monolithic concrete construction as well, because you are not creating any joint. You are casting beam, you're casting walls and slab together. So thereby there are no joints. That is why it is called monolithic. So the entire structure acts monolithically. So it provides wonderful or very good seismic resistance as well. Let's move to the next category, which is the last category. It is called a stay-in-place formwork system. This technology is being used in Lucknow. And why it is called a stay-in-place formwork system? In the earlier technology, once the the casting is done, this formwork is removed. Okay, so normally the formwork is removed. What about if formwork stays with the structure? So if the formwork stays with the structure, it is called stay-in-place formwork system, because it stays with the structure. And once it stays with the structure, it is it acts either as insulation or as the part of the structure. Part of the structure means it may act as reinforcement. So depending upon the purpose, it is called insulating concrete form or structural stay-in-place formwork system. Okay. This is the closure look. This, what you see again, this is expanded polystyrene. So these blocks, are customized and made in the factory, and through this block by block, you create the entire wall, and it's a load-bearing wall. And then this cavity between this 100 mm to 200, 300 mm as per your requirement. Then you cut the grooves for services and for openings and doors and all, and then you pour the concrete. Or if you want to go high rise, you can put reinforcement as well. Okay, and all these T joints, internal walls, all these are customized, and then block by block you construct and create the entire wall. So first it acts as a formwork, and later it acts as an insulation. Okay, and this technology we are using in one of our demonstration housing project in Bhopal, where this technology is being used, and in Lucknow we are using another variant of this technology. Before that, let me tell you that there were 8 companies which were shortlisted during Global Housing Technology Challenge, and the project which we are doing in Lucknow, we are using this novel assembler, which is a factory-made PVC stay-in-place wall form system. So I will show you a slide. So this is a pre-finished wall form system. Okay, so that system is being used, and so it falls under the category of stay-in-place formwork system. So these are pre-finished walls, okay, and they can be used as load-bearing walls as well as non-load-bearing walls. So this is that project in Lucknow which we are using. I have a slide. Yeah, so this is that PVC wall form. Okay, and so means you can just go and buy this wall, and this wall comes with different coloring option. In fact, in Lucknow we are using this, and we are using 3 colors. Okay, the gray, off-white, and mustard. So this wall, pre-finished wall, comes so it comes in form of components, and those in a specific width and to the full height of a room, and then through a slide lock arrangements, they are erected at the site in form of a wall, and then you can fill it with the lightweight concrete or usual concrete. Depending upon the application. If it is a load-bearing application, then you put reinforcement and do the concreting of suitable grade. If you're using it for non-load-bearing, then you can get away with the lightweight concrete. So the technology provider claims that it can be used for load-bearing applications as well. But in Lucknow, since the structure is S+13, so what we are doing, we are using it as an infill wall, and the structural system is of steel. Remember, I talked about the steel structure system, which is a hot rolled built-up sections of beam and columns, which are made in the factory and then connected at the site. And there's infill walls out of this PVC wall form, which is a pre-finished wall with different coloring options. So these are the 6 categories, and I hope you could get something out of what I told you. And in case you want to learn further about these technologies, so please do visit our website, bmtpc.org, or gst-india.gov.in website, or go to our YouTube channel. You can get detailed lectures on these technologies. In fact, what we have done, we have also created e-learning modules. Okay, so these are self-learning modules on the ministry's website. So if you are registered as Technograhi, you will get the access to these e-learning modules. So all these 6 technologies, each module is devoted to one technology. So there are 6 modules, and you take and through these modules we have in pedagogy, in teaching form, we have tried to explain all these technologies to you. So through that also you can learn about these technologies. If you want to download literature, technical details about these technologies, please visit GSTC website or our website. We have also, running a scheme called Performance Appraisal Certification Scheme, through which these technologies are being certified. There is one impediment in promoting these technologies, certification, because if you're working in a government organization, normally certification is required. Who has certified these technologies? So our ministry is working hand in hand with CPWD, Bureau of Indian Standards, and BMTPC is also running a scheme called Performance Appraisal Certification. Through these schemes, and we have certified all these technology. In fact, CPWD has approved all these 54 technologies. They have also developed detailed schedule of rate along with detailed specification for all these technologies. So if you want to use EPS panel and you want to know the specification, the welded wire mesh, the core, what is the thickness of plaster and all, you can readily get it from their schedule of rates, or otherwise you can visit our site and get the technical things downloaded. We are also working with the states, because through this Pradhan Mantri Awas Yojana, we are promoting and assisting states to make use of this information which we have, and we are also handholding them so that they use these technologies in their future projects. Like Andhra Pradesh, they used monolithic concrete construction in a big way. Chhattisgarh and Raipur, they have used already, precast concrete construction. In Gujarat was the first state to use precast concrete construction and monolithic concrete construction. Maharashtra, in big way, precast concrete construction is being used. In Delhi, more than 80,000 houses are being constructed with this precast concrete construction. So with this, let me end my lecture with this slide. And this slide, I just want you all to, I will just pause for a second so that you comprehend what does this slide mean. Okay, so through this slide, what I'm trying to show you that we are at level 0. If we look at the construction level all across the globe, so there are different levels, and so at present we are at level 0. Level 0 means buildable infrastructure. What we do, we do the estimates, do the tender, then get the material procured, get that material at the site, call the contractor, labor supervisor, and then start doing that project. So that is primitive level 0. Level 1 also, most of you might be familiar how there was a word called pre-engineered building or industrialized structures. All of you know how industrialized structures are being made, how those, the big bus stands, railway stands are being made. So they have a truss kind of thing. Okay, those trusses are, made in the factory, and then on the already erected columns, you put that truss and do the roof covering and start using that. So that is a pre-engineered building. So that is level 1. And level 2, level 3, and level 4. Level 2 is what I explained to you. Instead of, procuring material at the site, why don't we make these structural components in the factory or in the casting yard? Name the component, whether it is wall, it is column, beam, or facade, or your any material, any structural or non-structural element is cast in the factory and then transported to the site and erected at the site. So that is called level 0. Level 2. Level 3 is one level ahead than level 2, where instead of making these planar elements, wall elements, beam column elements, you make the entire room. So entire module. So, okay, so you can call it room, you can call it module, you can, it is normally called volumetric construction, or it is also known as a pod element. So you create these pods like building blocks in the factory and then put them one over the other to create the entire building. And level 4 is another level up where, in the factory itself, you put the finishes as well. You put the door, windows, and services, your seats and all, bathtubs and all, everything is put in the factory. In fact, 80 to 90% work is done. So this is called pre-finished building. All you have to do is bring that building to your site, and on the already laid foundation, you put that building connected with the services like water, sewerage, and electricity, and start using it. And that is why that level 4 is called plug and play homes. In fact, the Magic Reed, who is executing the project in Ranchi, the technology they are using, they are calling it plug and play home. So plug and play home means all you have to do is like you do for the electrical devices, you plug the device and start playing it. In a similar fashion, you can do with the buildings. And the good news is that all these levels exist in our country. It's not that I'm talking utopian or I'm talking something which we will be dreaming in next decade or so. All these technologies do exist in India, and already work is going on. In fact, we are doing 6 lighthouse projects using all these labels. And so I request all of you to think over it and try to bring this technology transition from level 0 to level 2, level 3, and level 4. And the advantages, what kind of optimization we can have, what kind of resource efficiency and other benefits we can achieve when we take a jump from level 0 to level 3 and level 4. And through these webinars, our attempt is to make you understand about these technologies, their merits, and so that you can use these things in your future projects. So with this, we come to the end of this lecture, and now we will move to the next lecture. But just to break the monotony, I will just show you a film of a project which was done with a hybrid system. We are using a hybrid system in 3 of our lighthouse projects. One is at Agartala, Lucknow, and Indore. So I'll just show you a film of L&T and DRDO. A 7-story building of DRDO was constructed in 45 days. Okay, a 7-story building in 45 days. And if you're interested in built-up area, it's 120,000 square feet built-up area. And it is done in India. And the other day, I was speaking in a program organized by GIZ. I told you there was 1 month back, there was a whole 1-page advertisement in all the newspapers by L&T and DRDO, where they have written that the technology, and they are using exactly the same technology, hybrid technology, which is being used in our lighthouse project. So I will just try to show you the film, and please bear with me if you are not able to get the sound, but because sound is not required. Sound रहेगी क्या देखना? Okay. First, I have to share. Sorry, I have to share. So let me share my screen first. Stop sharing. Share. Which one? This one. Okay. So, ये क्या करूं? ये क्या करें? Okay, छोड़ दीजिए. Sound come. So my system manager says sound will not come, but anyway, let me just show you this, and you should all get excited by this, what our country has achieved, and this triggered from this global housing technology challenge. Okay, so I will take a pause because it is self-explanatory. So just see. So this was the building which was, recently handed over to DRDO by L&T, and this was inaugurated by, Honorable Defense Minister. And let me tell you that the technologies, I think, if you have gathered, they have used exactly the same technology which we are talking about. They have used steel columns, they have used pod elements, they have used the mixture of all these things. Okay, so I'm trying to say, as per your requirement, time requirement, and all, you can tweak all these technologies and use them for your benefit. So they have used steel columns, they have used RCC columns, they have used customized form facades, they have used modular furniture, they have used pod elements for toilets and all. So it's a hybrid construction using those technologies which I showed you. Okay, so thank you very much for this, and now let me move to the next lecture, where we will be talking specifically about the Agarthala project. Okay, so let me share my screen. Can somebody help me if you are able to see my screen now?
It's visible.
Thank you, sir. Thank you. So, first I showed you 6 categories. So now you remember the 6 categories, and each 6 category, 6 lighthouse projects. And today we are at Agarthala. So we will be discussing this Agarthala project. And category used here is light gauge steel structural system and pre-engineered steel structural system. So in fact, I gave you the glimpse of this, what is this technology all about. But here I will try to explain you in detail this light gauge steel structural system and pre-engineered steel structural system. Okay, and because we are using steel as well as light gauge steel structural system, so it is called hybrid system being used in Lighthouse Project Agarthala. Also remember, Agarthala falls in a seismic zone 5, also a high risk damage zone, in the wind zone. Highest wind zone of our country. So as far as disaster resilience is concerned, these technologies are pretty good. Okay, this already explained you 54 technologies divided into 6 categories, and we are going to discuss this light gauge steel structural system. This is a slide to show you the glimpse, or in gist, or in essence, the 6 lighthouse projects which are currently going on in different parts of the country. Today we are discussing Agarthala. This category being used is here, and 1,000 houses are being constructed. Chennai project is already over, and as you can see, all these projects, lighthouse projects, have 1,000+ houses, and they are having different structural configuration, varying from 6-story structure to as high as 14-story structure. Okay, as I told you that all of you can visit these projects as per your suitability, or you can connect with us. You can register as TECHNOGRAHI. Every week or every fortnight, we are uploading the videos of the progress being made in these projects. So you can, and we are on a daily basis. I'm not sure daily basis or in 2 days or 3 days, we are also uploading the latest photographs of these project sites. So you can all see the projects growing at yourself by visiting our website. Okay, so let's see this. So Agarthala site, the total plot area given to us is 24,000, around 24,000 square meter, and the project comprises of 1,000 houses, which are spread into 7 blocks, which you can see in this in the layout, which is given on the right hand side. And what you see is 1, 2, 3, 4, 5, 6, 7. So these are the 7 blocks, and in addition, we have a community center, Anganwadi, and health center. For all these lighthouse projects, we have not only physical infrastructure but social infrastructure is also being provided. So there are 7 blocks, and the structural configuration is G+6. And if you are interested in a typical floor plan, so each this is on the left hand side, bottommost part you see. So there are 16 dwelling units in most of the blocks, but in some there are 22 dwelling units. So you can see, so there are 8 like this and 8 like this, so 16 dwelling units in each floor plan. And whenever we do this kind of big projects, we always keep some area clean. Some area is kept open and it is kept clean. So 31% out of the total plot area, 31% area is breathing space. So it is called a breathing space. Okay. And let me show you the typical dwelling unit plan. This typical dwelling unit plan for all the lighthouse projects varies from state to state and place to place because it is as per the requirement of state governments, and the state governments normally do approve this. But what we are suggesting them that the minimum area has to be around 25 square meter, minimum 25 square meter. It should have and toilet plus bath and a separate access from both the rooms. So this is the typical dwelling unit plan. And let me also tell you that we have a national building code. And see, for national building code, let me also share with you that national building code is a Bible for all civil engineers and architects. And all of you, if you are into the construction or in planning, you must have a copy of national building code because it gives you all kinds of norms, spacing norms, everything is being given, quality control, quality this thing, then design aspects, implementation aspects, technologies, everything is being given in that code. So national building code also specifies space norms for EWS housing. So space norm means the sizes of the room, height of the room, the width of the balcony, the total area, height of the building, width of the staircase. So all these dwelling unit plans confirms or are in line with the NBC 2016 norms. Okay, and as I told you, that most of the projects being executed all over the country under Pradhan Mantri Awas Yojana have 2 rooms and a separate access. So you can see that here they are not having they are having combined. So it was the requirement of the state government to have a combined toilet and bath. So that is why it is being proposed. Otherwise, in most of the projects we have a separate toilet and bath. Okay, and because these are model or pilot projects, so what we have done, we have given higher specification, very superior specifications are being given for these. Although these projects are EWS projects, but very high-end specifications are given, and we have added some special features in all these projects. Like use of renewable resources, solar lighting, rainwater harvesting, then solid waste management, and all these lighthouse projects have STP. STP is must, which is a sewage treatment plant with wastewater management. And wastewater management means you have to use the wastewater for secondary purposes, like for gardening purposes and for other for flushing purposes. Okay, and rainwater, solar lighting using LEDs and all the renewable resources, use of renewable resources. All these projects need to compulsory get a green rating of minimum green rating from as per GRIHA of 3-star. So all these projects are tied up with GRIHA council, and they need to secure at least 3-star rating so that these projects fall under the category of green and sustainable development. Also, most of you might be knowing that National Building Code suggests guidelines for firefighting services. So if your height of your building is more than 15 meters, you have to put firefighting norms into practice. So as per NBC, for all these buildings, for all these lighthouse projects, we have firefighting norms. Okay. So now the technology that we tell you, again, repeatedly, I'm telling you because I want you to understand what we are trying to replace. So this already explained you that we are trying to replace these construction systems which are in practice or which are in vogue or which are omnipresent, popular throughout the world by some other innovative system. So here, this framed structure is being replaced by this steel structural frame. Okay, and these are hot rolled steel sections which are manufactured in the factory. And then for walling, we are using this light gauge walling system. And these light gauge walling system, the wall panels are also made in the factory, and they are galvanized. Okay, so remember, these are thin light gauge steel, they are galvanized, so there is no problem of corrosion. And these sections are produced by cold forming. Cold forming means you have a hot rolled steel sheet, it is galvanized, and then it is put in a simple machine, roller forming machine, where you form it in a different sections, C sections and jet sections. In fact, I will show you a slide of its manufacturing. And these, once you have sections, then you can create the wall panels, and those wall panels are fixed in these spaces to create a light gauge wall panel. And then you put a facing sheets, which can be anything. Here we are using precast concrete panel, and in between space you can fill it with rock wool, mineral wool, or lightweight concrete. Here we are using lightweight concrete. So I think you understood. Skeleton is of steel, hot rolled steel sections, hot rolled built up steel sections, and walling is light gauge steel walling system. Okay, I will explain you these two again. And because we are using light gauge and these together, so that is why we are calling it hybrid system. And that is what was used in the L&T project I showed you. They have used hybrid. Instead of light gauge, they have used a concrete wall. Okay. I think you understood this. Let me now, one by one, explain you the various systems being used in this project. So I think most of you know, if we talk about the building and if we try to, understand what are the structural components in building. So building comprises of a foundation, which is the structural element below the ground. So this is called foundation. What you see here, and above foundation you have a plinth, and above plinth you have the structural system, which I told you is skeleton, which comprises of beam and column. Then you have floors and you have wall elements. So I will try to explain you all these structural elements one by one. So foundation, first come to foundation. The foundation for all these projects are based on this geotechnical investigation. Geotechnical investigation means soil investigation. And let me also, share with you that our country is a vast country, and soil strata varies from place to place. Like you go to mountains, you have rocky terrain. If you go to south, you have Deccan Plateau. So you have a again rocky terrain there. In a Gangetic plains, you have alluvial soil. Somewhere you have like MP and all, you have black cotton soil. So soil strata is varying from place to place. So depending upon the soil condition, depending upon the water table, depending upon your soil strata, the bearing capacity of soil, you can have different kind of foundation. Unfortunately, for the Lighthouse project at Agartala, the land given to us was a marshy land. It was the land was filled up land. It was waterlogged, and it was again filled up land. That water was removed, and then it was filled with filled up soil. So it was a filled up soil. Okay, so for this filled up soil, we need to have a filled up soil means like it was a waterlogged site. So bearing capacity was bare minimum. So we have to use, because the soil conditions are like that, so we have to use pile foundation here. Okay, I will show you different pictures of that pile foundations, how the piles are being driven. So this is what you see in the right bottommost right hand corner. This is the pile. So it is a 30-meter pile which is being inserted. And when you put a pile inside the ground, so that pile should go up to the hard ground. So 30 meter was the depth where the rock is being encountered. So 30-meter pile. Imagine 10-story building below the ground need to be put because the soil strata demanded that. Okay, so foundation used here is a pile foundation, and pile foundation, when you use pile foundation, just if you are an engineer, you might be knowing structural engineer. Otherwise, let me tell you, pile foundation is like columns. So you have columns, these piles, and then over that pile, you have, when you come at the ground level, you have to, connect those piles through pile caps or, through plinth beam and all. But because here it was a waterlogged site, so what we did, at the ground level, we have created again a raft of 500 mm, which is written here. And then from that raft, we have put the stem columns or pedestal. If you after the foundation, once you create the foundation, a footing over that column is being created up to the plinth level. So what we did, the first pile, then over that there is a raft, and from that raft, RCC pedestal, or you can say RCC column or stump columns up to the plinth level, and at the plinth level, all the columns were connected with the plinth beam. And once you have come at the plinth level with the plinth beam, then we put a base plate there with a nut and bolt. We erect the columns. Okay, so in fact I will show you that. So right now I wanted to tell you that because the soil condition was like that, we are having a pile foundation, and then over that pile foundation we are having a RCC raft, and then over that RCC raft up to plinth level we have RCC pedestal or stem columns, and over that stem column we have a plinth beam, and then we have a grade slab, and over that we are putting our steel structural system. Okay. So this is, I think, clear to you. The foundation is pile foundation, and once you have come to the plinth level, then you have to have a structural system. That is a superstructure. So superstructure comprises of these beam and column. Now let me also teach you here that Earlier, you might, earlier, during British time and in earlier times, steel was very popular. And all old buildings, if you go British era buildings, you will find, girders, eye girders and all. Those are rolled steel eye girders and all being put in the buildings across, to make slab and beams and all those kind of things. Okay. But with the passage of time, because, the steel prices are high and all, we stopped using steel as structural elements. But in pre-engineered buildings, they were being used. But now the technology has advanced, and now instead of rolled steel, rolled section means they are typical IS sections, which they come in. Some forms like I sections, J sections, C sections, angle sections, which are rolled up IS sections. But nowadays, you can have built up section. Built up section comprise, they are manufactured in the factory. So what you have steel plates of required thickness, and you create a I using those flat plates. So web and flange of those plates, you weld it and create a built-up section. So with the advent of this technology, the opportunities are enormous of using the steel structural system in building construction. Okay, so you can have a hollow section comprised. So imagine hollow steel, like you have a tube. Steel tube. Similarly, you can have a rectangular hollow section. So all over the world, for high structure, hollow rectangular sections are being used because the technology is advanced and we have this steel plate. So using those steel plate, you can create a hollow section. So here we are using that built-up section. So please remember, it's not a rolled IS section. It's a built-up I section which is manufactured in the factory. It comes in a form of I comprising of web and flat, which is made with the steel plates. So now I think you understood this. This is a structural system comprising of beam and column, which is built up steel, hot rolled steel sections. Okay. Now let's go to slab. So slab here is you might be knowing this is a deck slab. And deck slab also has a lot of advantages. Deck slab means it's not a cast in situ slab. All of you know cast in situ slab means what you do, instead of this decking sheet, you put a steel plate over that steel plate, which is called shuttering. So a steel plate over the props, the wooden bullies or steel, tubes, you put a, steel shuttering or steel plates, and then you put a reinforcement, and then you do a concreting depending upon a span, slab thickness, maybe 6 inches, 4.5 inches to 6 inches. So that is a typical cast in situ slab. But what we are doing here, instead of using cast in situ slab, we are using a deck slab, but it's called composite slab. So this is a deck sheet, which is a galvanized sheet of 0.9 mm. 0.9 mm, it's a profile sheet, steel sheet, galvanized. So first this sheet is put. So the moment you put this sheet, this acts as a shuttering as well. And once you are putting this sheet over this, a very nominal reinforcement is being put, and you just put a screed concrete of 75 mm, I think. 75 mm means 3 inches. So you have reduced the slab thickness from 6 inches to 3 inches. You have eliminated the use of shuttering. So it is pretty fast to put. All you have to do is you have to get this profile sheets from the market. Just put those profile sheet, put a nominal reinforcement, put that screed concrete, what is shown here in the bottom right slide, and you get the slab made. So floor slab here is made with this deck slab. Okay, so foundation I explained you, then structural system I explained you, and then this is the slab. Now let's come to the wall panels. So this is a slide to show you. If you are able to understand now, this is that one form of steel production is cold form, hot rolled steel, and this is a cold form steel. So cold form steel is again a hot rolled steel, but it is, these sections are cold form through a roller forming machine. Okay, so these sections or these structural elements, these are girders or these kind of wall panels which you see in the leftmost corner. These are the wall panels. Okay, they are made in the factory, thin, galvanized also. Galvanized means they are corrosion free. Okay, so these panels are made and they are being very light in weight. So 1 or 2 persons can easily lift these panels, and then you can create these kind of walls. Okay, and these can be used at the girders and at the slab level. So like this, you keep erecting these panels here and to create a wall. Okay, and then you can have openings, provisions for door, window, that is written for ventilators, other cutouts you can create. Then you can then to cover this from both the sides, inner side and bottom side, there are different options available. In this project, what is shown here is a 20 mm precast concrete panel. So this precast concrete panel is also being cast in the at the site. So here they are covering it with this precast concrete panel, and the space in between is filled with lightweight concrete. And this is a lightweight concrete is a concrete which is without aggregate. So it gives a great thermal insulation. Okay, so this is a unique technology being used. Otherwise, you go to other places, a typical light gauge steel wall frame system comprises of fiber cement board. So instead of 20 mm this, you have a fiber cement board, 16 mm, 8 to 12 mm fiber cement board, and that hollow space can be filled with rock wool or mineral wool, or some agencies are using lightweight concrete also. So please try to understand this is a light gauge wall framing panel which comprises of factory made wall panel components, and then at the site you have facing sheets. And these facing sheets, basically these are facing sheets or cladding sheets. So you clad this light gauge panel with facing sheets, which can be calcium silicate board, fiber cement board, precast concrete panel. Hyderabad Industries, they use AAC panel, so autoclaved panel, and it can be of thickness depending upon your requirement. Okay, so here we are using 20 mm precast concrete panel, and this core, the space between these two panels is filled. It can be filled with rock wool, mineral wool, lightweight concrete, or a proper grade concrete, or it can be EPS, elevated concrete also. Okay, so I think you understood this. So these, wall panels are fixed at the site over the already laid foundation. Please understand, for all these technologies, we reach up to the plinth level, and at plinth level, for this also we have a guided rail kind of system over which we put this panels, and then through self-driven metal screws, when you are connecting it with the foundation, then you have a nut and bolt system. When you are connecting two wall panels, then you have screws and all. So it's a very simple procedure through which you can very easily, pretty fast, you can create this wall. Okay. Now let me just show you, because the other day somebody asked me what is the difference between cold form and hot rolled steel. So this is the procedure to produce light gauge panels. So what you see here in this picture, the first photograph is a galvanized iron steel coil. So it is a hot rolled steel coil, okay, which is being put like this. So it comes in a form of a coil. Then this coil is straightened up through a machine. So you get this kind of coil. It can be cut also, depending upon the requirement, and then it is being put in a machine. So these are special machines. These are called roll forming machines. Okay, so there are a number of companies who are making these machines, and through these roll forming machines, you create these kind of sections. So this is a typical C section, jet section. So these sections you make, and then you create the perforations, dimplings into this, holes into this, so that services and other screws and all can be put. So, and once you put this, then you create this kind of wall panels as per your project requirement. So this is typical flow diagram for manufacturing this light panel. So you have a steel coil, then the steel coil is put into a decoiler to straighten that, then it can be cut, and then it is all computerized, industrialized, automated system, and then it is put into a roll forming machine, and you feed into the CAD machine your dimension of your sections, and once you put, you get this kind of sections, and then these sections are joined together to create your wall panels, and then that panels can be transported to the site, and then can be erected on the already laid plinth. Okay, another you can see this. So this is that sheet I was talking about, a coil of a sheet which is being put, and this is how this this is a lattice girder which is normally put just below the slab to take the load. So this is how it is. So any shape, any section can be made, and any kind of form can be made. So the typical, this is a lattice girder, then otherwise you have a wall panel kind of thing. Okay. So this is a typical wall panel, what you see here, and here we are trying to show, once you have come to the foundation level, how will you put this over, how will you connect your foundation with the panel. So what you have is, there are already, perforations or holes there, and you have a nut and bolt kind of thing. So with foundation, you need to create it with nut and bolt at a particular spacing. Okay, and we also have a code, Indian standard on light gauge steel frame, which is IS 801. All of you might be knowing a code for steel structure, which is IS 800. For this, we have a code IS 800. This code was, reaffirmed in, I think, 2008 or 16, and now it is being, revised as well. Okay, so now let me go to next slide. Yeah, so you can see here, yeah, this is clear here how it is being connected with the foundation, because this is very important. So, connecting it with the structural elements, beam elements, and foundation, you have to have, you need to use, this kind of nut and bolt. If you're connecting two wall panels, then you use a metal screws. So, this is a C kind of thing. So, what you see, this is this is a web, and this is a flange, and we are using 89 mm by 39 mm section here, and this is slightly put like this in a L shape here. So this is called lip, which is 11 mm. So it is a C section of size 89 mm by 39 mm, and the thickness of your steel sheet is 0.75 mm. So just imagine, this is a 0.75 mm thick section, so it's very lightweight. Okay, and these panels are, so what we do is, on a plinth level, we put a guide rail, and over that guide rail, we put these panels, and one panel over the other, create a wall section, and then, do the cladding or put the facing sheet. Okay, so as written, you can see here, it's written, these frames can be supplied in panel form or a knockdown condition. Knockdown condition means you get the panels and then create a panel at the site, or otherwise you can get the entire panel and just erect them at the site. And that is what is written. And then we have a self-drilling tapping screws. So self-drilling tapping screws means this is a screw, threaded screw, and just by tapping you can put that screw. So for jointing, all these screws come, and everything is pre-decided in the factory. All these screws, their locations, their perforations and all. So there is no need to punch any hole and all. Everything is just pre-decided, and on those pre-decided locations, pre-designed locations, you have to just put these screws or nut bolts and other things. Okay. Yeah. So these are the four kinds of screws we require. You have a steel frame, and with that steel frame, you have to connect this wall panel. So you require frame assembly screws. Okay, wall erection screws. So if you want to create wall to wall, then how will you create? So you have straight. So for each assembly, you have different kind of screws, different kind of openings. Now you have to create, connect cladding with the light gauge panel. So you have a precast concrete panel fixing screws. So all these are self-drilling drilling type screws, and for each assembly, you have different assembly: beam to wall panel, column to wall panel, foundation to wall panel, wall to wall panel, then facing sheet to wall panel. So for everything you have screws. So everywhere it is screws, only because foundation level you have to transfer the load, so you require anchor bolts. Okay, so high tensile galvanized steel anchor bolts of 10 mm to 100 mm. 100 mm is the length and 10 mm is the dia. So as per design requirement, these are the anchor bolts for connecting the wall panels with the foundation, and for other things you have a wall screws, self-cutting screws. This also explained you, this is for cladding. So once you have put these light gauge panels, then you put these cladding panels or facing sheets. As I told you, variety of panels are available, but here we are using precast concrete panel, which is of M20, and this is 20 mm. And the technology provider, they have set up a plant there itself. It's a very small plant. You require a concrete mixing machine and vibrating table with a mold, and you can produce these panels at the site. So these panels are being put, and these panels are then fixed with the light gauge panel, and the hollow space is filled with light gauge concrete. Okay, and for each panel, how many screws are to be put, everything is designed and given to the fabricator, to the team which is at the site, and so that they can accordingly install the wall panels. Okay. Now, this is for the, this also you must understand, this is the space in between is here in this project in Agartala. We are filling it with lightweight concrete. Okay. And this is a lightweight free flow concrete. I will also explain you what is the difference between lightweight concrete and a typical conventional concrete. Okay. So this is the lightweight concrete, and through pumping, this lightweight concrete is being put so as to have a solid feeling. Sometimes what happens, if you put it with a mineral wool and all, the hollow people, the residents are not comfortable with that hollow sound. So hollow sound. So to make it a solid sound or metallic sound, you can fill it with concrete and all. And you can see, you can see here. So here we are putting a concrete. Otherwise, this is a typical light gauge wall panel where it is stuffed or filled with this kind of puff or rock wool or mineral wool. This puff, no? Rock wool. So this is a rock wool. It is a rock wool here. You can see, and this is a fiber cement. Okay, so if you see the literature, most of the places you will find this kind of light gauge panel, but here we are using this special panel. And now let me tell you what is light gauge. So see the density of concrete is 24 kg per meter. Okay, and density of RCC is 25 kg per meter. And this lightweight concrete density is 1500 to 1800 kg per meter. And why we call it light gauge? Because we are not using aggregates here. Okay. See, concrete comprises of cement, sand, and coarse aggregate, or I say cement and aggregate. These aggregates are fine aggregate and coarse aggregate. Okay, so here we are not using coarse aggregate. And once you don't use coarse aggregate, the concrete becomes light. So these coarse aggregates are being replaced by, either by foam or there is aluminum powder through which you can create the voids. Here, what they are doing is, here instead of aggregate, they are using EPS bead. Remember, I told you EPS is a expanded polystyrene. So instead of aggregate, they are using these EPS beads, which are of very light density. So these EPS beads replace your aggregates. Okay, and like that you create this lightweight concrete. And being EPS weight is also known as elevated concrete. So with this, you get a good thermal efficiency as well. Okay, so this is how wall panel is being erected. This, I just wanted to show you that there are a whole lot of shop drawings you need to create, because whole lot of jointing will come, at the corner, at the T, how the girder is to be connected with the beam, with the column. If it is connecting at the web of a beam, then how it is to be connected. So all those details need to be designed and decided beforehand, and those shop drawings are given to the fabricator. So what you see here, this is a girder and this is the I section, steel section, how it is being connected here. So what you have is, you have some kind of, these brackets, so an anchorage bracket, connection bracket with perforation. So you put that bracket in the light gauge panel as well as in this, and then through screws and all, through welding. So there are a whole lot of options through which you can connect and create a monolithic structure. Okay, so advantages I don't need to go through, but it creates a very lightweight structure, and specifically we have used lightweight concrete here and light gauge wall panels because the Agartala falls in seismic zone 5, so this is being light in weight, and the moment you have lightweight means better seismic resistance, because lighter is the structure, you will experience lesser load during earthquakes. That is one thing. Second, if you have lighter load, then the sizes of structural elements, foundation, and everything gets reduced. Thereby, you have a cost-effective design. Okay, and these structural elements can be transported anywhere. And now the good news is the technology provider is trying to put up a plant there at the site itself for LGSF. So they will just be transporting the coils, okay, galvanized coils, and through those coils they will be making these light gauge components at the site itself. So you cut down with transportation cost, fossil fuel, because you require diesel for transporting these elements. So you cut down on greenhouse gas emission also. Also, it's purely a drywall construction. So walls, you require minimum water, and because frame, in fact, panel, everything is done in the factory, so you minimize on wastage as well. Okay, essential requirements, like for all the projects, because these are all these projects are being implemented with new technologies, so you require a little bit of training. A normal artisan or a labor cannot execute the project; they require a little bit of training. So most of the companies, most of the agencies, what they are doing, they are employing, or they are hiring the local laborers, and their experts or trainers come. They train that labor, and then that labor can be used, local labor, to erect these structures or implement these projects. In fact, all over the world, in fact, the big agencies like L&T, Rcc and all, they are also doing the same thing. They first give training to the local people, or the local artisans and then make use of that workforce for implementing their projects. Also, all these technologies are pre-engineered or precast, or everything is being done in the factory. So you have to decide these services, MEP services, mechanical, electric, and plumbing services beforehand. Because it's not like conventional construction where at a later stage you say, no, I don't want a bathroom here, I want a bathroom here, I don't want my electricity line to go from here. These things are difficult to do. Later, doing alterations at the later stage are difficult propositions. So my advice is that everything need to be pre-planned, need to be decided beforehand. Similarly, door window positions, because these light gauge panels, according to your openings and all, are made in the factory. So those door window positions are also need to be pre-decided, because it will be difficult to change it at a later stage. So you can see here what is written: post-construction alteration is difficult. So if you think, this is the limitation of this. Okay. Now, something on design and build basis. Just for the sake of all of you, let me tell you, whenever we are working with innovative construction systems and technologies, because we don't have enough capacity, so normally these projects are awarded on a design build basis. This was the model which was used by Highway Authority, National Highway Authority of India. It was very successful there, and from there now slowly it has come into the building, building construction and infrastructure construction as well. So design build basis means you just give a bare plot to the agency and ask him to build using his design. Of course, you give the specification and your requirement. So the agencies, per square feet or per dwelling unit, they quote the rate based on your specification. They give the design to you. That design need to be vetted by third party, and based on your approval, then they, as per their design, they build a structure. So this is called design and build basis. It is also called EPC contracting system. So EPC contracting system also has an advantage. The cost is decided before, and so it's not an item rate. See, in item rate, you have, for each item you have a rate. Here you give the rate per dwelling unit, and you pre-decide the specifications, and whatever the material is being put, whatever other elements, like door, windows, glasses, whatever it is, everything is decided before, and then you ask them to quote per square meter rate, per square foot rate, or per dwelling unit, depending upon the case. So that rate is fixed, and that rate is not altered. Okay, so that way it is advantageous, because at the later stage you can't change the rate, and that is why you avoid cost overruns. Okay, so in fact, in previous lecture I was telling you that when you do conventional construction, most of the projects become unviable by the time you finish them. Project started with 100 crore, it ends up with 300 crore because of item rate. So once you prefix the price or cost, there is no chance of cost overrun. Okay, so for this project, Mitsushimi Housing Private Limited, I think his proprietor is there, Mr. Ajay Shah. He's one of the leading company in our country who is into light gauge steel panel system, and in fact, he's doing a lot of projects with light gauge. But here, because it's a high-rise structure, and we are using it in CC Zone 5, so we are using hybrid steel, hot rolled steel with light gauge steel panel. So Mitsushimi Housing Private Limited is the technology provider as well as the implementing agency. In some of the projects, technology provider and implementing agencies are different, but in this project, the Mitsushimi Housing Private Limited is the agency. Okay, and why I'm telling you design build basis, that I just want to give you very quickly. I would like to tell you about design basis. Earlier, you remember, if you have to get your design approved, what you do? Normally, you submit the architectural drawings to the ULB, and they just put a stamp there, and that is okay, good for construction. Okay, and then in 2001, when Gujarat earthquake came, it was found that even the approved building, properly engineered building, framed structures, they in Ahmedabad, they collapsed, or if I use they fell like a pack of cards. There is a famous proverb in earthquake engineering is the building falls like a pack of cards. Okay, then it was decided that because when you are approving a drawing, you don't know the design basis, you don't know the sizes, reinforcement being used, and normally this is a misconception, as I was telling you, prescriptive design. So normally we think if we provide a column of this size and with these many reinforcement, the building will be safe, which is not the case, which is a prescriptive design or prescriptive guidelines. So it was decided that whenever approvals are being given, then those approvals need to be supplemented with design basis report, and that design basis report is structural drawings, and those drawings and design basis report need to be signed by practicing structural engineer. Okay, need to be signed by practicing structural engineer. Okay, and that is why we incorporated in model building bylaws, and by state governments were asked to have the design basis format we have given. So in design basis report, what kind of forces you are taking, all those things are incorporated, and that need to be vetted by the structural engineer for approval from ULB. I don't know about Tripura, but I know about Delhi, I know about Gujarat, I know about my state Uttarakhand, where this is being practiced. Okay, and Gujarat is being done, structural engineer Delhi. If you go to DDA and you want to get your building or structure pass, so they will give you a form in which there is annexure which says a structural stability certificate, and when you get it signed from structural engineer, it will have there is another annexure which says design basis. So I just wanted to show you that design basis report. All these projects have design basis reports, which is vetted also by third party, which is IITs in most of the cases, because innovative technology. So we are not taking chances. All these designs which are being put to us by the agency, they are being vetted by the third party, which is in most of the cases IIT. Okay, so design basis means what kind of loads you are using. I will not bore you with this, but the loads. What are the loads? Loads for a building are dead loads, live load. Live load means depending upon the use. Suppose you are designing a theater, then that load will be higher. If you are designing a residential building, then dead load will be less. Similarly, depending upon your location, wind load varies. So what you see here, this is a map from the BMTBC's Vulnerability Atlas of India, and this is a map which is given in National Building Code 2016 as well. So this map gives the wind speed in various locations or various parts of the country. So you can see the country is divided into 6 wind zones, highest being 55 meters per second. So as you can see, Tripura, this Tripura region falls in a very high damage risk zone as far as wind is concerned, 55 meters per second. So the structure need to be designed for this wind load. And let me not get into this wind load. This is a basic wind speed which is converted into a design wind speed depending upon the location, depending upon the layout, depending upon the high rise or rise of the building, depending on the topography, and then you convert it into pressure and put that load as a design load for analysis and design of the building. And earthquake load is very important. And this slide I have been showing to everyone that in our country, it's a fragile country where earthquakes keep coming. Recurrence of, repeatedly earthquakes are coming, and you can see the entire northeast area is red. Red means danger. It is a very high seismic zone. It is a zone 5. Our country is divided into how many zones? 4 zones. Okay, 2, 3, 4, 5. So northeastern region falls in zone 5. And and this is a seismic zoning map of our country. What we have done is we have put this map in a GIS platform. We have a document called Vulnerability Atlas of India. All of you can get the access of this Vulnerability Atlas of India through our website, or we have a dedicated website with a name called vulnerabilityatlasofindia.com. So you can just get an access. And before embarking upon any project or before preparing any DPR, please look for the hazard profile of that place where you are working. Hazard profile means what is the wind speed, what is the earthquake speed, is it prone to floods, is it prone to landslides, does that site have any other kind of hazard, land subsidence and all those things. And depending upon that hazard, you incorporate those features or those design parameters into your DPR or into your structure. Okay, so this is let me not get into this, but what you do normally, a seismic coefficient depending upon the zone is taken from the code, and then that seismic coefficient is multiplied with the weight, the total weight of the structure to get the base shear, and then that base shear is distributed at all the floors to do the design and analysis. So there is a code 1893. So always remember there is a code 1893 which gives the earthquake load. So also you need to decide beforehand that what kind of structure you are designing, whether it is a moment resting frame, shear resting frame, special moment resting frame, ordinary frame. There are a whole lot of structural things which I don't want to get into detail. Whether columns are fixed with the beams, whether there is monolithic connection. So all those things need to be decided and need to be incorporated in the design stage to know the base shear and to know the earthquake load. So you know all the loads, light loads, wind load, earthquake load, and then you carry out the structural analysis. This is just a list. I just wanted to see, whatever you do as a good engineer or architect or as a good professional, always follow these codes religiously. I would say I would use the word religiously. Always follow our codes. India has a good amount of codes. Earlier we used to say that we don't have codes and all, but for earthquakes, we talk about anything you talk about, we have good amount of codes, and all these codes need to be referred. So for loading, these are the codes 875. If you remember, 875 is the code for loading, except earthquake load. For earthquake load, because earthquake is a dangerous load. So for the earthquake, initially we have kept 1893 as a code for earthquake. So this is for load calculation. Similarly, because it's a steel structure, so IS 800 is the code for steel design. For light gauge steel design, IS 801 is the code for steel design, and 456 is the code for RCC design. Okay, and when you are doing RCC design, there is something called detailing of reinforcement, how reinforcement is being put, how the stirrups are being put, what is the spacing, how it is being bent, what are the U-clips and all those kind of things. That comes from the detailing code. So remember this code also, 13920 is the code for ductile detailing. So all these codes. Another thing is, earlier it was difficult to get access to these codes, but nowadays these codes are available online. In fact, BIS, they have taken a great initiative. So you can go to their website, create your own user ID, and get some of these codes. These important codes, at least you can download free of cost. Okay, so foundation also, I will not get into that. So once you have calculated the load, prepared the design basis report, decided what kind of frame structural scheme you are using, you need to analyze your building for so many load combinations. Okay, so there are 30 load combinations for which your building need to be analyzed and designed, and for the worst possible load combination, these buildings are designed. Okay, so overall, there are 13 load combination, and you design your building, your structure for the worst possible load combination. Okay, so you have live load, earthquake load, wind load, and their various combinations. So it cannot be done manually. You need to resort to softwares. So there are a whole lot of softwares available. Some of them are written here: StatPro, ETAP, SAFE, SAP, Abacus. So any of the software you can use. Again, most of the softwares are developed outside, but now all these softwares, they have incorporated Indian standards as well. So it's very easy to make use of this, to create a model of your building, put your loading, and then design the structure. I've been using this word analysis and design. Analysis means when you put these loads, you will get to know that your each structural element is subjected to what kind of movements and shear forces. And for that movement and shear forces and other axial forces, that particular structural element is being designed. Design means what should be the size, what should be the shape of the structural element. If it is a RCC element, then what amount of reinforcement is required, what percentage of reinforcement. So that all these things come from structural design, and which is very important. Once you do the design, once you do the analysis and design, then you have to put everything in form of drawings. So earlier we used to have draftsmen and all, and making those big, blueprints. Nowadays, AutoCAD has made our life simpler. So I also, advocate that as civil engineers, we should also have some knowledge of AutoCAD so that we can understand these AutoCAD drawings. So AutoCAD is also must when we are doing this kind of design basis or analysis and design. Okay, and let me also tell you, despite of doing all these things, all these buildings are designed for two limited states. One is limited state of collapse and limited state of serviceability. That means that during the service life, in the event of any extreme, in event of any extreme event, means even for the worst possible natural hazard, the building should not collapse. So for that building is being designed. And during the service life of building is also designed for limited state of serviceability. Means there will not be perceptible, visible cracks or damages in the building. So it is designed for these kind of limited states. Like if you have a RCC beam, so it should not deflect. It should not deflect as much so that it is visible from the naked eye. So that kind of precision is being taken when we are doing design and analysis, but that design need to be translated in the field, and that is done through quality control and quality assurance. Okay, so I can do a good design, but if I don't execute it good, then I will be creating a bad structure despite of using innovative technologies and good materials. Okay, so execution and good execution can be ensured through quality control and quality assurance. So that is also must for all these projects. So now I think the difficult part is over. Now I will show you some pictures of the progress being made. Again, I will take that in this sequence: foundation, structure, system, and LHP. So I just don't want to get into this, drawings as engineer, as supervisor, the team at the site. They are given a set of structural drawings, and through that structural drawing, you get to know where your pile is coming, what are the locations of the piles, where the shear walls are coming, where the columns are coming. One thing I forgot to tell you that we are having piles, and then we are having a stand columns or pedestal at all locations except at lift wells and staircases. Why? Because at staircase well and lift well, the loading is higher than your typical floor level. So there, instead of pedestal, we are having RCC shear wall. So from the pile we have a raft, and from raft we have a shear wall here. And at other places we have a RCC column or sub column. Okay, so that shaded portion what you see is a shear wall portion. Okay, and this is a typical section of your pile, and what you can see here, if you are able to see, this pile is as long as 30 meters, and its diameter, it's a circular pile of 600 mm, which means 2-foot pile of 30 meter is driven below the ground. Okay, so this is a typical section, and you need to provide a helical reinforcement. I have other drawing which I threw up. I'll show you that. Okay, so this is again the section closure look. So these, you have a pile, and then over pile you put a raft. This raft is around 500 mm, and then over that raft you start putting those columns, and wherever we have lift well or staircase, there we are putting these shear walls. So these are shear walls wherever we have lift wells in this, and on other places we have columns. Okay, so I think it is understood, and up to this, from this we reach up to the finished floor level, and at the finished floor level, these columns and walls are connected with a plinth beam. Okay, and over that plinth beam, we insert on and wherever plinth beam and column are coming, and those columns we insert cast anchor plates, and with anchor boards are being cast, and on those anchor boards columns are being erected. I will show you through the pictures. Okay, so again another schematic view of foundation details, and what you see, this C kind of thing is your shear wall, and what you see, this black rectangles, these are the position of your pedestals. So these are those pedestals. So pile, over that pile you have a raft, and over the raft you have pedestal up to plinth level, and wherever we have lift well and staircase, we have this kind of shear wall. I think it is understood. So again, another section which is cut at the pedestal level. So what you see here, you see the this is a raft. Below raft you have a pile, and then you have this. So this is a pedestal. You can call it RCC column. You can call it stem column, or normally it is called pedestal. Okay, so this pedestal is being put, and it is being terminated at the plinth level and connected with plinth beam, and then you are casting these boards here, and you are putting a anchor plate, and this anchor plate, through this anchor plate, it is being connected with your steel column, which is manufactured in the factory through nut and bolts. This also I will show you. Okay, so this is just a section. So so now you can see here. So once we have reached up to the plinth level, so these, this is a typical, this also you must understand. So these anchor bolts, again, their dia, their length, threaded length, the length which is going in the column. All these things are designed because there are a lot of loads, because ultimately or the load of the entire building is transferred to the foundation through these anchor bolts only. So these anchor bolts are properly designed. Then we put the sleeves. These are steel sleeves which are inserted, and in this non-shrink grout is being put so that we have a proper transfer of load and there is no slip and all at the anchorage level. And it has to be perfect. So what we do is we create a template. So normally a base plate is fixed in the factory with the column. So we create a template of that, and with that template, the locations, exact locations of these anchor bolts are earmarked, and then bolts are inserted and cast with the stem column and twin beam, and then we will put the nut and bolts with this base plates, which is shown in the topmost slide. Okay, so this is that this is a structural drawing for anchor bolt and base plate, and this is how. So this is what I wanted to show you. Again, you just let me just explain you. So this is that anchor bolt. So just think, if we don't give this bend, what will happen? So structurally, if I have to tell you as structural engineer, it increases the strength, overturning strength by 2.5 times. So just by putting this 90-degree bend, the overturning strength is enhanced several times. So it's a small bend. So these kind of detailing need to be done instead of having this. If you don't have it at 90 degree, if you had a 45 degree again, so again the overturning thing will be reduced. So it has to be at 90 degree, and it's a common sense. And these the embedded length, then this threaded length, depending upon the dia, it is designed, and as per design, you put these anchor bolts in your stem columns. Okay, so anchor bolts are inserted below plinth level up to height h, and then projected over plinth level for this T-threaded line. And then depending upon the loads, you design the dia as well as the number of anchor bolts required. So on a base plate, you put these anchor bolts. So this again a structural drawing of plinth beam, as I told you. So these are the plinth beams which are coming only at this here. You are having shovels, otherwise you have plinth beams. So all pedestal columns are connected with plinth beams, and wherever we have these stem columns, there we are having through base plate, we are connecting it with the steel columns. Okay, so that was the theory part of this, and now let me show you the foundation. So first of all, because it's a marshy land filled up with water continuously, water was through pumps and all, water was ejected, and then layout referring to the structural drawing, wherever we have piles. So those carefully you have to mark. You have to create a benchmark, and then from that benchmark you have to clearly mark the locations of your piles, and then boring is to be done. And these are called cast in situ bored piles. So what you see in this is how it is being bored, and this is a hydraulic rig. It is called hydraulic rig, or it's a agar. Okay, so earlier, if you are not going for, nowadays we have this hydraulic rigs, and in our times we used to have mechanical rigs. So you have a tripod kind of system, and then you insert that rig manually. Okay, nowadays very easily you can go up to 30 meter and 40 meter. And imagine if rock is encountered in between, a local rock, and now that need to be cut and it need to be inserted properly. So first you create this bore through this hydraulic rig. Then what you do, you put a reinforcement cage, and then you may have a water coming out, so then you have to put a slurry, bentonite slurry, to stop the increase of that water. Then you have to put a reinforcement cage, and then if soil is much, sometimes soil also caves in, so you have to put some kind of a stabilization to prevent the falling of that soil, and then you put a reinforcement cage, and then you do the concreting. And there are around 1,750 piles in this project being used. Okay, and the length is 30 meter below ground, and the diameter is 600 mm. So this is that reinforcement cage I was talking about, and this is that circular rig, which is also very important. This is called helical reinforcement. So first they will make this reinforcement cage, and then through that hydraulic rig you create a bore, and then in that bore you put this reinforcement cage, and then you do the concreting. I think I have a picture. Yeah. So then you have a hopper kind of thing, and here they are using a ready mix concrete. So this ready mix concrete is being put through this hopper of a particular depth, and then again you keep on putting and come up with the ground level. Okay, so you see that's what is written. Once you flush out the borehole with bentonite slurry, so that ingress of water is prevented, pouring of falling of soil from the sides. Then you pour this concrete, and again the grade of concrete is again decided. Here it is being used M30. It's a higher grade of concrete because we are doing casting below the ground and piler. And then once you come to the ground level, then you will put a raft, which I think I have a picture of that raft also. Again, a closer look, you can see. So this is that pile we are talking about. Now what they are doing, they are filling up here, they are putting a concrete like this. This is a closer look, and this is the finished pile you can see. So once the pile is over, then normally, the pile is put, and then what I was telling you, up to a particular height, you have a pile, and after that, here this pile is removed, and this reinforcement is exposed, and this reinforcement is connected with the pedestal, and wherever you have shear wall with shear wall, as well as with the raft. So as to have monolithicity, because you have to connect pile for smooth load transfer. You have to connect your pile with the raft and with the column, and that column with plinth beam, and then plinth beam to the your steel column. So, and everything, it should flow flawlessly or smoothly. So for monolithic or for structural integral transfer or monolithic transfer of load from the structure to the pile, this is the normal practice. So this is a pile of 30 meter, and this is around 2 meter. So this 2 meter is cast extra, and then later this reinforcement is connected with the raft. I will show you in the next slide. Okay. So this is again a closer look of that, you can see. And now you can see. So now this reinforcement bars are being bent for insertion into raft. And now you can see for raft also, you have to do a plane, the ground is undulating. So you have to first put a PCC of M7.5 or M10, and then over that PCC, you will put the raft. You can see, so this is a PCC. PCC is a plain cement concrete, which is being put, then it is being cured, and then you are laying the reinforcement of raft. And this is how it's being done. And then over the raft, you are putting again. So what you see here, this is a stub column, or the pedestal column, which will get terminated at the plinth level with plinth beam. So it will be terminated at the plinth beam. So you have this raft. This raft is 500 mm, around 500 mm. So this is the reinforcement, and then we will do the casting. So now the casting is being done. So reinforcement and casting of stub. So everything is being done together, because you have laid the concrete, you have laid the reinforcement cage. So this is how it is being done, and now casting of stub column is being done over the raft. So you have a formwork for that stub columm, and then you pour the reinforcement. Again, a closer look. So what you see, these are the columns, pedestal column, and what you see on the rightmost side, this is a shear wall. So as I told you that at the lift and the staircase level, we have a shear wall, otherwise we have a pedestal column. So I think you understood. We have a plinth, we have a pile, over pile we have a raft, over raft we have a pedestal column, and over that columns are terminated at the plinth. Everything is connected at the plinth level, so as to erect these steel columns. Okay. So you can see now this is the plinth level, and these columns have already been cast. So, and they are being cured. So, you have to continuously cure. Another good practice is to cure your concrete. Okay, so that it gains strength. Okay, there is heat of hydration, and the heat of hydration is to be offset by continuous curing, and at no point of time your surface should be dry. So thereby, that is why this kind of Haitian clothes is being put. Sometimes ponding or ponding with water is being done, so that for 14 days, this 14 to 21 days, this curing is being done, so that it gives strength. Okay. So now let me see whether I have a slide. Yeah. So these are those columns, and then you can see the plinth beam reinforcement is being put. So you see. I think it is clear from here now. I think this is a wonderful photograph which shows you. So we have what you see, gray thing is the concrete thing is a pedestal. Okay, that now over that pedestal, wherever we have pedestal, we will be having a column. So now you can see this is a base plate which is being put, okay, with the anchor bolts inside this, and we have a plinth beam. So now everything will be cast together. Okay, so all columns, why all columns are being connected with plinth beam? Again, remember this, that when you are dealing, when you are doing constructing in a seismic zone 5 or 4, you need to ensure structural integral action, or box-like action, or monolithic action. So if you don't connect these beams with these columns with beams, so each column during shaking will have its own settlement. Okay, all these columns will shake or vibrate in their own fashion. And if we connect all these columns together, so that means we are having a box-like action. It means the entire thing, the entire platform, foundation platform will shake together. So which is very robust system, and there will not be any damage. And that is why this such a heavy plinth beam is being put, and all these columns are being connected at the plinth level. So now I think it is clear to you. You have a column, then you have a plinth beam, and over that plinth beam you have anchor bolts. And as I told you, these anchor bolts are to be carefully designed and carefully detailed and to be put carefully, because the base plate is coming from the factory welded with the column. So you have to have a template, and there have to be it has to be accurate, and then through nut bolt you will erect those columns. Okay, you can see this is for shear wall. So there I showed you the pedestal. Here I'm showing you the shear wall. Okay, so you can see this. Now this foundation bolts are being fixed. You can see. Okay. So this is over. So up to this we have come. Now over this we will put the steel columns, and each steel column has a length of 6 meters. So I will show you how those columns are being. So this is just a slide to show you that what is the grade of concrete and all. And then whenever you're doing such a big project, you have to have a mixed design. Mixed design is also being done by IIT. Then piles, whenever you're doing pile, as I told you, that quality control and quality assurance is very important. So as per the codal requirement, I think 10% piles. 1%, sorry, 1%. So out of 1750 piles, 1% piles need to be tested under dynamic load. So there is a code, a dynamic load test for piles. So those piles are being tested for cracks and all, and for structural integrity. So these piles are designed. So here I think piles are designed for 70-ton load and some later load. So for that load, the pile is tested for its structural integrity. So this is a test which is being going on. So this is a batching plant, quality assurance. The testing laboratory is also being put for all these projects at the site, so that at the site itself you can check the quality of concrete, you can check the quality of other materials using these compression testing machine and see where all. So structure, unfortunately, because time is consumed in this project for drawing, for driving those piles. So the progress at present, because of site condition, very few columns have been erected. But whatever columns have been erected, I will just try to show you. So we have come up to the plinth level. I think majority of piles out of 1750, 1700 piles have already been cast. Only 50 around 200 piles are remaining, and then but they have also started the work on superstructure. So this I will not show you that somebody may ask that when you are doing in zone 5, what about the moment resting frames and all those kinds of things. So based on our codal requirement, you can have beam column connections, column connections, and those all column connections, beam column and beam column connections can be designed as moment resting connections, or shear and moment resting connections, or only shear connections. So if you connect it at the flange level, then it becomes shear. If you connect at the web and flange level, then it becomes the moment resting frame. So as per your requirement, wherever you want the print to be formed, so shear and moment resting connections depending upon the connection size. So all these connections, beam to column, column to beam, shear wall. Now you are having concrete shear wall. So how these beams will be connected with the shear wall. So there is a typical detail which is giving. So you have to cast a plate in the shear wall with lug with lug bars, and then you have to have a cleat angle. That cleat angle, through that cleat angle, you will that a steel beam is fixed with the base plate or the third plate. So all these connections can be done. So this is the shear wall in superstructure. Now let me show you this is how the column is being erected. So this is a 6 meter column which is made in the factory with a base plate. So you have this bolts here. So over this bolt, a base plate will be pushed, and then nut and bolt will be put to put this columns. And what you see, this rectangular thing here, and at these levels there will be beams. Okay, so already the holes are already there, and a plate is being welded. So with this, through nut and bolt, you will put a beam here. I think I have a slide. Yes, you can see. So now, once you have come to the plinth level, at the you have those anchor bolts, and then through anchor plates, you erect these columns, and then you erect these beams. So now you get these spaces, and in these spaces, you put these LGSF wall panels. I think I have a slide. So this is again a closure look. You can see here. So this is that built up I section. Then these are the beam sections. And this is that shear wall section. Okay. And this is that light gauge panel. So this light gauge wall panel, the entire panel is made in the factory because the size is less. So the entire panel is made in the factory, and it will be put here, and then it will be connected with the soffit of your beam, and the you have a flange of a column. And as I told you, with the foundation, it is connected through anchor bolts. So once you put this light gauge panel, then you have to put the facing sheets, which I explained to you earlier. Okay. So with this, I think this again a closer look you can see here. Yeah. So I think from this it is clear. This is that pedestal. This is that base plate. This is now, you have a plinth beam, and over that here, once you have come over the ground, then you have to put up wall, dwarf wall it is called, to contain the soil inside. And this is that light gauge panel. That lattice girder also I was telling you, to transfer the load of beam, you have to have a continuous member. So this kind of girder, lattice girder, is provided here. So this is again, everything is made in the factory. Okay, so unfortunately, the progress is this much only there, so we are not able to show you much. Let me quickly, this also I explained you. This is that just for your academic interest or for structural interest, this is the profile. This is the schematic deck sheet profile. So it's around 60 mm high. So 60 mm is the depth of this, and it's 0.9 mm thick. So it is put over the already laid girders, and then what you do, you put the reinforcement, nominal reinforcement, and then you do a 75 mm deck, screed, concrete screed, and over that you can put a floor finish. Okay, so it can be done very easily. It's a deck slab. So this is how it is being done. Right now, this position, this is not from this side. This is from other side. Just wanted to show you how slab is being put, and now this is how the concrete is being screed. Okay, so this, I think I have already explained you the construction process, that how it is being done. First, you come to the foundation level, then concurrently you can make the LGSF panels, then those LGSF panels and steel sections are brought to the site, and then already laid foundations through that anchor plates. You put the steel columns and beams, and then you erect these steel columns, and then put the concreting and all. Okay, so this is just this is not a picture from this project site, but how beautiful it looks, you see. So this is a picture. In fact, I have done under Pradhan Mantri Awas Yojana, we have done 2 projects using these light gauge projects, which I will be showing you, one in Panchkula and one in Hyderabad, Telangana. And there is a question of all services can be very easily can be put, because you have this kind of, so we already put I told you we have a perforations here, so through that perforation you can put all kinds of services, mechanical, electrical. And then this is a roof roof slab, so this is a light gauge roof slab, so you can very easily you can put the electrical cables and all those things. And now this is again, you can see in a light gauge you can fix the tiles, and you can put any kind of Indian seat or a Western seat or any kind of wash basin can be put. And you can have any kind of pressed steel door or a UPVC window frame, or any it's compatible with conventional fittings and all. So this slide just shows you how services are being put. Only thing is you have to pre-decide this, and you have to put this before putting this facing, before doing the concreting of this panel. Okay, and just finishing items, we are using pressed steel door frames with flush shutters and PVC door for wet areas, and for doors for window frames we are using UPVC beige panels with wire mesh shutters. Everywhere vitrified tiles are being used except in the wet areas. Wet areas we are using anti-skid ceramic tiles, and common areas normally coated stone is harder, so coated stone is being used in common areas staircase slab. And this also explained you that there are a whole lot of other features which can be emulated by in your other projects, like use of solar lighting, then street lighting using LED, sewage treatment plant, use of wastewater. Then horticulture facilities are being provided for all these projects. PRIA rating of 3-star is must. Then stormwater drains. Whenever you have roads and all the roads need to have RCC stormwater drains. Then rainwater harvesting is also need of the hour, and that is also included in this project. Okay, and also there is because it's a high-rise structure, so it's not only staircase, but in fact in all the lighthouse projects we are providing staircase as well as a lift core panel. So lift and staircase both are being provided in these projects. So that is all about the lighthouse project at Agartala, and this also I told you, and I am repeating it for the benefit of all of you, that if you want to know more, if you want to get connected with this project and want to see the live status, or you want to see the progress on a daily basis, we are uploading the photographs from the site. So you can visit this gstcindia.gov.in, and on tab menu, in the tab menu, you can look for the Lighthouse project. Click on that Lighthouse projects. You will get all the 6 Lighthouse projects listing. Click on any project, put the date, put the tower number, and you will get to know the live status. And you can also see every fortnightly, we are also uploading the video films from the project site, so you can access those video films also. In case we will have a interactive section as well, if time permits. Otherwise, you can always write on our website, on our email, gstc-mhua.gov.in. If you have some doubts, you can write to Ministry's website, or you can directly contact me, and to the best of my knowledge or my capability, I will try to answer you. So thank you very much for being part of this webinar. I'm sorry if it was too technical. I tried to make it as simple as I could. So with this, we end this session. And if you have some questions, you can write in the chat box. We will take those questions which are in the chat box. So in the meantime, I will also show you another film. It's a 1-minute film, which is, there is a project, done by Precast, with Precast concrete construction in 45 days during COVID time. So I just wanted to show you that. It's a 1 minute, so please bear with me. Yeah. Yeah. So this is a Precast concrete construction during COVID time. It was done. You are able to see, all of you?
Yes, sir, it's visible.
उसे स्टार वाले को
So this is during COVID time using Precast concrete construction. A hospital, 3-story hospital, constructed in Tamil Nadu.
ये आज पूरा
You can see this 69,000 square feet. Thank you. Thank you very much. I will just remove the sharing. Okay, stop sharing. Okay, thank you very much. If you have some questions, we can answer those questions. Nobody has written any question. Okay, there is one question on corrosion. Okay, that's a very valid question. First of all, light gauge steel is galvanized. Okay, so you should understand galvanized means aluminum and zinc coating. Okay, and it's of 150 gal volume it is called. So that is corrosion. Now let's come to steel structure. So this is again a misconception that steel can be encased and it will not corrode. In fact, I showed you one drawing, which is my favorite. I showed you one blue steel structure. So that was the structure which was recommended by me in Visakhapatnam. Visakhapatnam falls under aggressive environment. It's a coastal environment, but we have a code, which says in case, in aggressive environment, you have to put a coating. Okay, so there are coatings available through which you can make it corrosion free. Okay, so corrosion is not a problem nowadays with the advancement in chemical technologies and all. Okay, so there is another question. Can you provide the PDF file of all project site in details, including drawings, so that we can go? Very nice, Mr. Aditya Roy. It's already available. As I told you, you go to the ghtc-india.gov.in website. Okay, look for the project, and there we have given PDF files of all the drawings and other things. Okay, so you can download, and in case you have any problem, just let us know. We will try to help you out. So there is no other. Let me see. So there is no other question. If you have any other question, please ask.
Sir, should we try and show the live feeding?
Oh, sorry, I forgot. Oh, I'm sorry. I'm sorry.
It's all right, sir. We'll try and connect the cameras so that people can view the live progress of the project.
Sure.
So the connection is very, very bad, but still we'll manage to show the progress. I think the agency is planning to show the viewers two things. I think first is the piling work, which is currently going on. And is there somebody from Mitsumi connected? Ravi? Ravi from Mitsumi, are you connected? So this is the live feeding that we are getting from Agartala. It's kind of evening right now, but the work on piling is going on. Maybe we can connect with Ravi. Okay. So this is the site which is almost, I think it is very close to the international border of Bangladesh and India. And a lot of smart city work is happening there. We'll try and connect the camera. Oh. So the news is it's raining in Agartala right now. There is no light. So whatever we can see through the CCTV camera is visible. Otherwise, there is no light, so we will not be able to operate the fixed cameras, which is giving us the live feeding. Is there somebody who can show us the work through its phone or something?
Yes, Ravi. Please share your screen.
So it's drizzling there in Agartala as usual, and connection is going. Okay, Ravi has come up with his own screen. I think we'll इसको बंद कर देना, आप अपने screen को sharing को बंद कर दो. It's very slow. I think the connection is very slow, but we'll still try and see the possibility if we can see some of the work happening. No, I think Ravi, you'll have to share the screen once again. So these are the disadvantages of the places like Agartala, which are so remotely connected. Yeah, so screen of Ravi is visible. I think he's connecting his phone. Okay, one of the advantages that Ravi can go to the site and exactly there where actually the work is happening. I don't know what he's doing.
I'm just sharing right now.
Okay. So if you can switch on your camera is off.
Yes, sir. Yes, sir. Just wait a minute, sir.
Yeah. Great.
Sir, now is it visible, sir?
Something is happening, but you'll have to connect So we can see the pile work which is happening there.
Yes, sir.
Mhm. Yes. So we can see now. Ravi, can you tell me if the piling is still going on?
Yes, sir. Right now, just we have casted a one pile. Then after done this one pile, we have to start second pile for casting. Preparation for second pile casting.
थोड़ा सा और आप नजदीक जा सकते हैं क्या? थोड़ा दिखाओ ना वो the pipe which is going on inside. वो जो frame दिखाया था आप लोगों ने वो दिखा
right now,
दीजिए.
sir, actually there is a heavy rain right now here.
Okay.
We have one pile here right now. Then we have started casting for second pile.
Mm-hmm. Can you show the other part of the project where you have steel structures coming on?
Yes, sir. Yes, sir.
Yes.
ECC Mauritius.
थोड़ा सा और नजदीक जा सकते हैं क्या?
Yes, sir.
जॉइंटिंग वगैरह अगर दिखा पाए तो.
Yes, sir.
बारिश हो रही है तो
I think it is important for the participants also to consider the condition which is actually the
harsh condition.
condition. So this is the part which Shailesh sir was showing in the presentation. Okay, great. Sir, you want to add something? This is the actual.
I think it's all explained to them, so there is nothing to show at site right now.
Right,
Because
right.
manual driving is a simple thing, and we can't show even fixing of that LG. So it's good. Okay, keep it up. At least do the progress. To the site engineers.
Moreover, they have rains right now.
It's a difficult site, we know. So I think if you can show something, it's so okay, Ravi. Otherwise, if you want to show something to the participants, fine. Otherwise,
नहीं दिख रहा है. फायदा नहीं है वो.
हाँ नागपुर है क्लास
ये
चलो फिर Manish, I think it's all right. So
लगता है बारिश से इसके कारण
Sir, we'll move forward. I think it is.
होगा नहीं.
so I think Manish, you want wait for some more time, or otherwise we wind it up.
And we'll continue, sir. We'll go ahead with our next session. I think if you have any question or something.
Okay, so there are no questions written. In fact, if you have some questions, you can always write the questions to us, and these webinars are being organized in association with the Climate Smart Building section of GIZ, and we have with us Vikas Ranjan, who is also co-hosting these webinars with me and Manish. So I will ask him to propose vote of thanks, and after vote of thanks, may we request everyone to switch on their video so that we can take a virtual group photographs.
Thank you very much, sir. It was nice evening, basically, and where you have explained everything on technology part with respect to LHP Agartala. It is my privilege and great pleasure to thank you all participants here today for the 6th webinar and live feed demonstration of the Agartala LHP, being organized by MOHUA, BMTPC, and GIZ. You all are the real ambassador of this projects. So I would like to thank Mr. Kuldeep Narayan, Joint Secretary and Mission Director for Housing for All, who is steering this complete project from the front, and extend my heartfelt thanks to him. And always, he always be present himself and given this event valuable attention, although he's not here today because of his occupations. Despite his busy schedules, he always tries to join these webinars to interact with the participants and encourage them to have further learnings to these live laboratories. And again, I would also like to thank Mr. R.K. Gautam, the director of MHUA, for his constant effort to bring these LHP technologies to the newer heights. My special thanks goes to Sri Salesh Kumar Agarwalji, ED BMTPC, and his team to bring these innovative technologies for the first time in India, an idea of having live laboratories for field learning to students, engineers, architects, developers, and professionals. Hats off to you, sir. And I sincerely thank Mr. Manish Kumar, Regional Coordinator of MHUA, and his team for bringing this naive idea of conducting these live feeds and technical webinars on LHPs. This will be continued and featured on rotation basis. So participants, you will see many more construction developments happening in a span of 1 month. So we will be rotating our webinars as well to different LHPs. And finally, I would also like to thank the LHP Chennai site project partners, technology provider, GSZ CSB teams for providing this site input to the participants. Thank you all. Thank you all participants.
So, okay, so if you can, all of you can switch on your video so that we take a photograph. I see Akhilesh, I see Kana.
Can everyone switch on their video so that we can see your face and we can click a picture? This picture will also go on the website along with the presentation. Thank you very much. Yeah, more and more people are coming. Few more. Yeah, make it grid. Yes. If we can see a few more faces. Thank you. Thank you, everyone.
Okay then. Okay then.
Yeah.
Hi. So thank you very much, all of you.